That's all. But
It's not very advanced. I need to duplicate or something. I just love Southeast Asia, and then I have a few like unblocked.
รูปมันดูพิเศษจอขึ้นป่ะ
I go for Miyata.
Mirror.
Yes, yes. This is like
No, I was teacher trainer. I was workshop teachers.
This one.
No, it's quite less because polytechnic teachers don't go to NI. They are professionals. So when they come to polytechnic, each polytechnic has its own level.
Yes, yes.
Understand students to show them how to create assignments.
So you are the master teacher.
Not really. More like technology. So that's why from Monday to Friday I focus.
Okay.
Friday evening I go.
Okay. So you
ปัญหานี้คือไม่
I
ทำไมมันไม่เข้า
มันไม่เข้า
มันไม่เข้ากล้องหรืออะไร
I used to live in
มันไม่เข้า
ไม่มันของทูมันต่อตรงกับที่นี่เลย
No,
ไม่เกี่ยว
so now
Who
I'm saying I
โหลโหล
read
โหล
a
โหลคือ
But earlier my wife is from Japan.
โหลโหล
She was also living in Singapore. She was
มันควรจะเข้าไลฟ์ดีครับเราได้ไลฟ์ด้วยอ่ะ
But she likes she stuff.
very good. Yeah.
Is it okay?
There's that old
Okay.
photo. What the name? Very famous. Yeah, Chop.
Okay.
So you join this idea or?
Right from the beginning, first year. Because I know many years. I used to organize conference in Vietnam. That's how
ไม่ตัวไหนวะ
I still
Oh.
You still do Vietnam often or?
Yes, once a month.
I don't know anything.
Okay.
Oh,
It's actually SDs. It's a user group. It's
Sort of is not toxic.
so you are helping people like getting into the field.
I used to give hiring process.
ไม่รู้จะเทสเพลง
You
อะไร
may know Michael Cheng.
โอเคขึ้น เข้าเสียงตอนนี้เข้าแต่ว่า
But he also does the junior dev SD.
Yes.
พี่ลองพูดนะพูด
โหลสวัสดีครับ
มันอยู่ไมค์ไหนโลนี่พี่ลองพูดไมค์
โล
นะ
โล
They
โล
used to be in
โล
Arab Street, but now
Go.
Is with Mr. Roman?
yes, yes,
แต่มันไม่ขึ้นเลยอะไม่ออก
yeah,
พูด
yes, yeah.
Yes.
จะออก
Yeah, because I used to organize a party every year.
Oh, always. You actually can.
No, so what happened was earlier it was only bar.
ฮะ
Then we opened the bar.
เดินไปไกลพี่ลองพูดหน่อย
โหลครับสวัสดีครับผมสวัสดีครับ
You would have all kind of
ไม่ใช่อ่ะว้า
you know, how to find a girlfriend.
เฮ้ยโอเคพี่ตัวนี้มันออกจากเครื่องผมเลยนี่หว่า
Luther and all, they say, oh, we will do a special gig.
ที่อยากไปนะน้องแบบที่
So they kind of separated from market, but they made
พนักงานคือแบบ
purely content.
I think they
อันนี้เราพูด
พอเสียพอไอซีนะดีพนักงานดีนะครับผม
So until 2020, we had last year, 2024, last year we did. I think
เป็น
now
น้ำเที่ยวนะ
the venues are getting really expensive. So I don't think it goes on concerts.
I've been there for a couple of years.
เราจะต้องให้ผมมาเซตใหม่นะผมไม่รู้ตัวไหนอะ
จริง
Python or?
No, I'm not.
ตุ่มตั้งตุ่มโทรหาไหม
Many years back, I was
ตุ่มตั้งตุ่ม
really like
So whatever you do now is not related to
technology. I mean, of course, everything has technology nowadays, but I don't actively work in technology.
โอเคไหม
ยังไม่มีเสียงเลย
Early on, I used to program.
คือเสียงมันไม่เข้าไหน
ไม่ออกมาจากจอผมไม่ได้ยินเสียงเลยมันอาจจะเข้า อันนี้แล้วผมอยากรู้ว่าไมค์ตัวไหน
typically what are some of the
ไม่มันจะเข้าได้จะไหน
ใช่พี่เขาจะเอาไมค์ไหมเสียงไมค์ไหมต้องเอาสิ
ไม่
So they are, we have our
ต่อด้วยเหรอไม่
They have some-
เอาพี่เพราะมันมาจากตัวนี้
These days, most of
ใช่
them don't deliver.
เอาพุทมาจากตัวนี้
ตัว
They have a standard
แต่ว่าไมค์มันไม่เข้าตัวนี้ด้วยซ้ำ
อืม
canvas right space for all the properties. And then they would have
ถ้าพูด
some
พี่พูดไหน
add-on system.
ไม่เข้าอ่ะ what the fuck bro
These days, we
Slow.
what's happening
software funds because of the privacy. They don't want students investing in some other stuff. So everything is like trying to control. So most of it is like and of course people will use pattern some of those software.
So you understand how to use better?
No,
Am I?
they don't use
Test,
it.
test, test,
It's
test.
more like let's say you're setting up a site. How you design
Test,
a site
test.
so that
พี่ต้องเรียกผมแล้วล่ะ มันจะ11 โมงแล้วพี่
first more using Gen AI. It's like event graphics, like how to get student using Gen AI. But now we have moved on to like how to actually infuse AI. So students use AI to do some part, and then you can measure what
About this and
ไมค์มันไม่เข้าตัว
my quality is 500.
มันเป็นไมค์ของ
so you run this
ไมค์จอ
เราต้องเรคคอร์ดส่วนถามดูว่า
อันนี้มาดูเสียงเรื่องเสียงหน่อยจะได้ให้ผมมาดูเรื่องเสียงเสร็จผมน่าจะไม่มีอะไรทำแล้วล่ะพี่เดี๋ยวดูผมโอเค not sure โอเค test 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 ไม่เข้าอ่ะผมที่ชี้แกตัวนี้มันไม่พูดยังพูดแล้วอันนี้คือมันออกเดสก์ท็อปพี่เนี่ยมาจากจอเครื่องพี่เนี่ย
พูดนี่เอาไหมล่ะ
พี่ลองเช็คจากตัวซอฟต์บ็อกซ์ว่ามันอุ้ยไม่มา
เทสผ่านแล้วเข้าห้องแม่ง
ฮะใช้ได้จริงใช่ไหมตัวเหี้ย
ใช่ได้เดี๋ยวก็
กดไดเรกมอนิเตอร์ยังกดไดเรกมอนิเตอร์ยัง
กดแล้ว
ไอ้ซิกแนลมันขึ้นไหมตรงเนี้ยตรงในเนี้ยไม่ขึ้นเหรอ
มันเป็นตัวโค้ดใช่ไหม
กดดิกดไหมไม่ได้ต้องกดเป็น
audio interface ใช่ไหม
test the slides. Where your slide was because I put it in the Dropbox. Yes, this one. This one, right? Yes. There's a link in the. Yeah.
อะไร
test
ออกมาแล้ว
อ้าวมาแล้วไม่รู้ลองปรับดูอ่ะเดี๋ยวพี่เองโอ้ยโหลครับสวัสดีครับสวัสดีครับสวัสดีครับสวัสดีครับสวัสดีครับสวัสดีครับสวัสดีครับเสียงฮัลโหลครับฮัลโหลฮัลโหลฮัลโหลฮัลโหลฮัลโหลฮัลโหลฮัลโหลฮัลโหลเทสเทสเทสได้ยินไหมโอเคนะโอเคโอเคโอเคโอเค
ครับผมเรียบร้อยครับ Hey put it in the room with me last year I talked to you
What? Hirok.
อีหลอก
What? Hirok.
อีหลอก
Last year you attended?
yes yeah
ฮะอะไรวะ
กูจะไปรู้เว้ย
ไปทำอะไรเขาไว้ไอ้ยันน้ำไม่เย็นไม่เย็นดูเลยน้ำไม่เย็นไม่เสียบปลั๊กปลั๊กก็เสียบปลั๊กก็เสียบเอ้าเปิดดิ Hello you speaker
yeah can I just check my plan
yeah you can check it on
So everything is on air.
can I
hello 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 Samsung อ้าวไม่อะไร
ปลาพันกล่อง
ฮัลโหลโอ้ยเสียงแตกอะ
เสียงโคตรแตกอ่ะ
พี่เป่าอะไรทีเนี้ย What
Is there time for Q&A?
Q&A
question yes ทำไม why
Everything in 15 minutes.
yeah is okay โอเคจุ๊บไม่เขาถามว่ามี Q&A ไหมหรือว่าทุกอย่างโอเคไหม
เช็คกันดิ
ฮัลโหลไม่ออกข้างเดียววะเทส
ออกข้างเดียวเหี้ย
เทสฮัลโหล one two three โอเค
no
โอเค one โหลเทสโอเคฮัลโหลฮัลโหลเทส one two three four ฮัลโหลเทส1 2 3 4 1 2 1 one โอเค
yeah
โอเค
sorry
Hello. Yeah. Hi, I will be talking about Floss Fund, a little bit about me. I'm Ansha. I work as a program manager at FOSS United Foundation. We are a non-profit organization trying to promote, support, and enable an open source ecosystem in India. I'm also part of the team at Floss Fund, which is what we will be talking about today. But but before that, a little bit of history about the organization behind Floss Fund. It's called Zerodha, which is the largest stockbroker in India. They've been one of the biggest advocates of free and open source software in the country. Over the last 5-6 years, they've done sizable investments in the open source ecosystem in India. In 2019, they invested in ERP Next, which is the largest open source project to have come out of the country and is the world's largest free and open source ERP system. They co-founded the FOSS United Foundation, which is the organization that I work at. In 2023, we launched the Oasis Alliance, which is an initiative to help the social sector or non-profit organizations or civil society adopt open source. How do you enable very small organizations to adopt technology, and specifically open source technology, so they don't have to sort of pay, for expensive software? And then in late 2024, we launched Floss Fund, which is an initiative to contribute $1 million a year to free and open source projects. FOSS United is an ecosystem partner with the Floss Fund, wherein we are helping them with outreach, evaluations, communications, and also making this more community driven. But to sort of go into the reasons of why we felt the need to launch something like this. Of course, everyone in this room, we all already know, right, how prevalent and significant open source software already is. So there's no debate about that. But even with the success of how prevalent it has become, sustainability is still a question. It's a problem that we've still not been able to solve. So that is, of course, one of the things. And the rise of the open core model, it is, of course, interesting, but with the amount of rug pulls that we are seeing and licensing changes and projects becoming closed source, it has become a concern to the open source ecosystem. Large amounts of VC funding in open source is definitely not looking healthy. Why are Python libraries raising VC funding? Just something off about that. So yes, for us, Floss Fund is about goodwill, reciprocity, and of course, if you are benefiting from open source software, you as a company, it is your ethical responsibility to give back to the ecosystem. But more than that, it's also just a good business decision. For example, if you are using an open source software and you are deriving value out of it, it will harm your revenue if that project stops getting maintained tomorrow, or if the maintainer stops working on it. So the sustainability of that project is, of course, should be of importance to you, and it should make sense for companies to sort of give back to the ecosystem. And why we launched this program specifically was to add more structure to how we sort of give back to the ecosystem. Over the last decade, the organization has been informally donating to open source projects, which was very awkward, because you come across a project, you reach out to them, you ask them if they, you send them an email, which is, of course, also a task, and then you ask the maintainer, hey, we would like to donate to your project, what can we do? Then the maintainer responds after a few weeks. They tell you, okay, yeah, here's my donation link or whatever, and then you ask them, how much do you should we donate? And it just becomes a very awkward conversation. So we wanted something more formal. How do we sort of build that structure to give back to open source without having these awkward conversations? So this is what the structure of the program looks like. We've set aside a pool of $1 million to give back to open source projects annually. There is a small team. You would be familiar with the term open source program office. We call it the open source funding office, a group of people within the team who are just responsible for these decisions. And there are plans to make this more community driven and sort of eliminate the organization as a whole, and the free and open source software community should be able to decide how to sort of evaluate these decisions. The funding range looks like 10 to 100K USD per project. We've also launched something called the funding JSON mechanism, which I will talk about. Funding JSON is an open JSON manifest that we are reaching out to projects to apply to sort of create. The idea of funding JSON is to make funding requirements of open source projects more discoverable. For example, how every project has a README file today. The funding JSON manifest is supposed to be like a crawlable, easily available link on the internet that then your scrapers or your crawlers can pick up, and just to make the funding requirements of projects more discoverable for anybody who wants to donate to a project, or you want to find out how sustainable that project already is. this is what the schema looks like. So there are 3 sections to the manifest: the entity, which is the organization or the person who is writing the manifest, the projects under the umbrella, and then the funding channels. So the entity could be, for example, a non-profit foundation that is governing the said project, or a maintainer, or the sole creator of the project, and then their contact details. The projects, of course, if you are, for example, a non-profit foundation that is governing projects, what are the projects, what are their repository links, and all of that. And then the funding channels: how does one donate to your project? GitHub sponsors, Open Collective, or a bank transfer. What are the plans? For example, you could have like a $10,000 infrastructure plan wherein you want somebody to pay for your infra costs or buy you new hardware, or a new feature that if somebody were to donate X amount of money, you would be able to work on a new feature. So those are what the plans could look like, and then the history of what the project's funding has been. The funding JSON experiment over the last year and a half has been a good success. Some of the biggest projects in the world have already applied. All of these will be familiar names. We are also working on platform integrations. We are working with GitHub to make a nudge for the funding JSON files. For example, whenever you create a repository, you get a nudge to create a README file. We are working with GitHub on something similar to that for the funding manifest, and again integrations with F-Droid, thanks.dev. With the fund itself, this is what the applications have looked like over the last almost 500 days. 500 plus projects have applied. A total of $11 million has been requested, which I don't know if it's a good sign or not, because that just shows how unsustainable the ecosystem actually is. These were the projects that we funded last year. You will see some familiar names: ImageMagick, of course, Krita, FFmpeg, you will notice here, OpenStreetMap, Blender. So about the good parts, of course, some of the biggest FOSS projects in the world have applied to the fund, and there's also great diversity that we've noticed in the applications. So programming languages, developer tools, or social impact and humanitarian projects. We've received applications from projects that are doing disaster response and all of that. So great diversity overall, and a diversity in the entities as well. So we've noticed applications from non-profit foundations, collectives, open source maintainers, creators. And all of this has come in organically through outreach and us presenting at events like this. We've not had any campaigns or something like that to get in applications. And of course, the funding JSON experiment has done reasonably well. But all of that said, the biggest disappointment with the fund has been the fact that we have just not been able to send out money. This figure is a little older. A few payments went out last week, but still somewhere around 450K or something like that. So we've only been able to disburse half of the amount we committed last year, owing to legal reasons, compliance, regulations, and a lot of it. Just how difficult it has been to send money out of India to open source. That is not something we had an idea that it would be a hard process, but just donating money to open source out of India has been a really painful challenge. And even with the projects we've been able to send out the money to, the timelines have looked like anywhere from 4 weeks to like even months, which is just a lot of paperwork that has been required from the project's end, and then a lot of accounting and legal discussions that need to happen. You need to create agreements and all of that. All of this we had some idea, but we did not know it was supposed to be this hard. We've tried a lot to work with platforms like GitHub sponsors and Open Collective, but so far that has also not worked because of the nature of regulation. So we've only been able to do bank transfers, which is a fairly complicated process. So the lessons from running the program, a bunch. The first, of course, is sorry for the text wall, but the basic lesson has been running a non-thematic fund is very hard, because how do you sort of evaluate the diversity in the projects, right? It is so hard to sort of understand how much money you give to such important projects. So we've for example, so this is basically the criteria we've been able to come up with on how do you go about evaluating your applications. First and foremost is, of course, is the project a critical piece of infrastructure or a foundational block? Then it is a no-brainer, right? What does its usage look like? What are there existing alternatives to these projects? Are there existing open source alternatives to this project? or is this, you know, for example, one project out of many in reasonably crowded space, or is it perhaps the only FOSS initiative of its kind? It could be an open source alternative to a very popular proprietary service, for example. In that case, it makes a lot of sense. But some of the projects that I've applied are also very niche. For example, something in the scientific Python ecosystem. That is a very niche application, but how important that project is to that particular niche has become one of the evaluation criteria. So overall, it may not be very relevant, but still to that particular domain or particular niche, it could be a very critical project. So we have to consider all of that. Is it crucial R&D work that can benefit the FOSS ecosystem? And of course, then you look at how well the project has been doing financially. Does it already have a lot of donations coming in which case you would probably want to donate somewhere else, right? Involving the community is a very essential process. Again, just the diversity of applications we've received, it is very difficult for 4 or 5 people to sort of be able to evaluate all of these projects. Some of them we've used, some of the names we've heard, but some projects we just come across for the first time. So talking to the broader community, people who've used these projects, contributed to them, maintainers, that has been very valuable. And so anybody who's thinking of setting up a similar initiative should really think of that angle. How do you sort of create a community around your program? And there is a formal proposal with the FOSS United Foundation on how do you eliminate the Zerodha organization that runs the fund and sort of make this community driven. So we are going to set up a community voting process which will decide how the evaluations take place, where do you direct the money. The second learning, the other learning has been a lack of fiscal clarity. Again, when we started the program, we knew it will be hard, but we've been very surprised by how how surprised the projects were when they sort of came across the program and we reached out to them that, hey, we would like to fund you. And they were very surprised at the amounts of documentation that is required or the delays that happen when you apply for certain documentation. For example, the IRS takes around minimum of 45 days to issue you a tax residency certificate, which is something that you have to submit to sort of prove that you are based out of a certain country, right? So all of that, one learning or advice basically for open source projects that apply for programs like this is, it is hard, but do read up on your tax laws, do keep some documents handy which will be of use to you, or a funder that wants to donate to your project, because it is genuinely a very hard process. And yeah, also be the timelines do look very strange, so be comfortable with that. But yeah, the biggest lesson, of course, we knew when we started the program that open source is unsustainable, but for certain projects, because of how popular they are, you would expect that, okay, at least this project should have money, right? But no, some of the biggest projects in the world are still struggling financially, and it's just very hard to explain why big tech doesn't donate or do enough for open source, but that is still the reality in 2026. All of that said, for next year, these are our plans. We've already allocated a fresh amount for the next year, the next $1 million pool. And we are very serious about making this more community driven, how to set up voting mechanisms to conduct evaluations. We are going to push harder we are talking to banks, we are talking to the government on how do you make donating to open source easier. Can we get certain exemptions to make that process faster, smoother, or more, sort of require less documentation, for example. We will continue talking to platforms like GitHub and Open Collective on how we can work with them to, sort of make this work out. And this year, another plan is to advocate with the government to set up a sovereign FOSS fund in India. A lot of these efforts already exist in the European Union, and we are very passionate about setting up something like this in the country as well. And lastly, of course, more outreach for the funding JSON mechanism. Yeah, that's it. Call to actions: if you're a FOSS project, please apply. If you're a company that is benefiting from open source, please pay your share. Yeah, you can reach out to me. We also have a booth at the event, the FOSS United booth. Please feel free to reach out if you have any questions.
Yeah. Thank you. Thank you, Raj. How are you doing this out of India? But you already answered that. Yeah. So it is
Um, so I had a question of, are there any Indian projects that you have direct, like, and how has the experience been in that sense?
The Indian projects that we funded, thank you. You will see Ente here, which is an open source alternative to Google Photos, and Rethink DNS, which is an open source firewall. There, the experience has been fairly simple because we just have to send an invoice and it's all done. So maybe 1 week is what it took.
Okay. And this might go a little too much detail, but was this considered like a donation or was this considered like a service?
This is considered a service agreement where we send them a support agreement or a service agreement, but the line that we state is that the service you're providing is the continued development of the project.
Okay.
So it's not really that they are giving us, support or something, but it is an agreement, yes.
Yeah. So basically my concern is, will this attract a bunch of GST and stuff?
There is a lot of tax, yes.
Because
GST, I'm not sure, but there's also double taxation when you're sending money outside. So 10% at our end, 10% at the project's end. But if you make it a service agreement, the project can claim the taxes back when they file for returns.
Okay. All right.
Any other questions? Matrix is here. We've still not been able to send them the money because of how hectic it has been. But yeah, sorry for that.
Okay, just a quick thing. Like, is the second speaker here, Aditya? No. Then you can. I mean, if you have more questions, you can continue. Okay. Thanks. Thanks, Anshay. Anyway, thank you.
No, I'm just saying Aditya is just outside.
Oh, really? Okay.
Yeah, I think he has a booth.
Okay, I will look. Thanks. Thank you, Ansh. Yeah.
Yes, speaker?
11:35.
11:25? Yeah. You can set your eyes in there. Okay.
I will try to. Sorry, are you Aditya?
No, I'm at 11:35. I'm just checking. Excuse me, I couldn't see my presentation. Yeah, actually I sent an updated one,
But this is the. Oh, you are the third one, isn't it?
Correct.
Yeah. Okay.
but I sent an updated one.
Okay. Do you have it on your computer, the new one?
Yeah, I have it on my computer.
Okay. Maybe you can try connecting because our second speaker is not here, so you can just try. You are number 3, I think.
Correct.
You are.
Or can I copy using a USB stick?
On this computer, I don't know. Maybe yeah, you can. Yes. Okay, I'm still going to try to find.
We are supposed
Hello. Hello everyone. It is nice to see you here. So I'm going to talk about the genome's journey to sustainable community-driven funding. So I'm Aditya. I'm one of the foundation member of the Genome Foundation. And if you want to connect with me in LinkedIn, then you can just scan. So you all know that Genome is a desktop environment, which is the default one for some of the popular distros like Ubuntu, Fedora, OpenSUSE, and even the Debian. If you don't choose any desktop, your preferred desktop environment, then the Genome loads up. So what we know is Genome has millions of users all around the world. But the problem is Genome has very little funding. So for nearly 30 years, Genome has been a cornerstone of the open source ecosystem. It has been powering the Linux desktop for millions, but the financial reality right now tells a different story. So how Genome actually is funding? So how it is funded is through the grants for specific initiatives, through the advisory board, through the conferences like GUADEC, which is the annual conference which happens in Europe, and there is Genome Asia, which happens in Asia, and also the end user donations. The end user donations is the most underutilized, but it is the most important and the most promising one. So very little funding exists for the broad Genome initiatives. We are though grateful for contributions from people like Canonical, and then Red Hat, SUSE, and Endless, but again it isn't enough. So we needed to change the landscape because the funding started become more and more less, and it started to become the problem for the project. So what changed was corporate sponsors have shifted their priorities toward cloud and enterprise, because as the development has happened right now, folks are more interested in cloud and enterprises things more than the desktop environment things. So one is that thing changed from the previous time, and another is desktop focused funding steadily plateaued, and relying on few large benefactors become unstable. So what we realize is for the long-term resilience, we require grassroots supports, support from within the community, and supports from the users. So million of users means massive untapped potential for the fundraising, those who are using the project itself. And also what we realize is other projects have already moved on to the community fundraising like KDE, Thunderbird, and Blender, and they proved that community funding works. So we needed to build our own sustainable funding model, and we looked to our peers for inspirations. Some of the inspiration we took away from the KDE folks. So at first what we had to do was we had to redesign our Friends of Genome. So what is Friends of Genome? If you donate to Genome, if you support it, then you are counted as one of the Friends of Genome. So before we had a janky iframe embed on genome.org, which didn't really look good. It was a confusing donation option, and the user experience and design was poor. There weren't clear donor perks. There weren't anything specific that you will get if you become the friend of Genome before, and it was hard to find and hard to share. So now what happened right now is we have made a clean dedicated mini site. It is powered by Stripe. It is just simple and reliable. So you can just search donate.genome.org, and you can see there the clear recurring tiers with relatable pricing, and then there is a small perk that your name on the supporters page, if you become a Friends of Genome, then you are displayed there, and it is easy to link and promote everywhere. So what we mean by relatable tier membership is we started with 3 tiers: seed, grow, and sustain, and we made it relatable through the phrases like seed is the price of a coffee with a friend, so it is just $10 to $15 per month. Then grow is the price of a movie with popcorn, $25 to $50 per month, and then sustain is the price of a meal in a fancy restaurant, so $102 to $50 per month. So how do we let people know about donate.genome.org? So at first we started by being vocal. So we really are trying to get it in the blog post, the release notes, and social media. And in the social media, we are celebrating the milestones. We are posting about it. There was a end of a year campaign which we did in 2025, and then we had the goal to push to the Friends of Genome to the number of like 1500 Friends of Genome, which was shared across all the channels. And then community advocacy is always there, like through the talks like this, and then post, and then sessions. So in Genome 49, what we did was we started asking users directly. So if you use Genome 49, then you might have seen a small pop-up which says donate to Genome, and then it is just an occasional notification, one-time notification, because we don't want to irritate our users. We just want it to feel like more natural. And then it is respectful and non-intrusive. And another is you can find a persistent banner in the settings if you are using Fedora, that there is a support genome banner in settings, and then you can go to about, and then you can directly see there is a banner for donate.genome.org. So this timeline is also important. Genome 49 released mid-September 2025. And then it was shipped with Fedora 43 only in October 28, because this is key to understanding, because you can see here in the stats the results. We started the year-end campaign in July. So at first we had new subscribers. So in the first month we had 98, and then 50, and then 89, and then the Fedora 49 released with the latest genome, and then all the notification started going, the one-time notification, and they can see the persistent banner. So we had the rise in the number. So when Genome 49 was released, we had 143 Friends of Genome, and then it again rise the new 206 numbers of Friends of Genome, and then the number has been going good. So it shows that the new Friends of Genome strategy is working, and the community is really supporting, because they want to donate to this software which they really love using. And then there have been recurring revenue growth, month by month growth. If you see in the percentage, every month there is a revenue growth, and the initial surge in July reflects the relaunch, and October's 51% spike aligns with Fedora 43 shipping with latest Genome 49. And if we see the key numbers, then the recurring revenue growth has been increasing by like 225%. We have been doing it since 8 consecutive months, the campaign. And then there are new peak subscriber growth, which went up to 81.6% in September, and then peak revenue spike went up to 51% in October. Is the latest Fedora was released with the Genome. And now if we see what worked for us and what were the challenges during these fundraising campaigns. So what worked was clean, dedicated donation site really worked. It helped us to represent what we needed, what we are asking with the users, and then how they can make the difference in the project. Another thing that worked was in-app notification. So the Genome 49, which came with the pop-up, was a single biggest growth driver. And then we had the relatable tier pricing. So previously what happened was there wasn't any fixed prices. So right now there is a fixed price which we can relate or we can resonate with the people with the phrases like price of a coffee or price of a popcorn, and it really worked well. And we started celebrating the milestones, like we started posting the increasing number of friends of Genome if we are hitting the milestone 500, 600, 700. So it really helped us represent ourselves in the social media and show them that the campaign actually is working. And if you want to help us, if you want to donate, or if you want to contribute, then you can do too. So there were few challenges. The few challenges were the post-launch normalization. So if you see, the numbers grew at the time of the release, like the Genome 49 release and the Fedora 43 release, but then again the post-release, what started was it started become normal. So the numbers started coming down. So one of the challenges is to maintain the consistency of the numbers, or make it grow and grow every month. So another big challenge was the diverse global user base. Since Genome is used all over the world, and we are pricing it in like dollars. So what happened was, currency confusion and varied economic context makes one pricing hard. So one size pricing is hard, because if you see the $10 to $15 per month, this is the price of a coffee with a friend. And this can relate to a lot of people, but I cannot relate it personally because I am from Nepal, and it is much more expensive for me to pay this. So this was and this is always a challenge to maintain a uniform metrics, because in every country and every region the pricing differs. So we have to solve this challenge, and we are still thinking about the solutions. And some other challenges are, like for the country Nepal, we cannot do international payments. So even if we want to donate, we cannot donate to the projects that we really love using, and we love them to sustain, but then we cannot help because of these payment issues. So what your community can adopt from the campaign that we are doing, if you want to start community fundraising like us. So the first thing to do is build a dedicated frictionless donation page, so that the one who want to donate, they don't get confused, and they know how much they need to donate or how much they want to. And we can use technologies like Stripe or similar to make it really easy. And then use your software to ask for support, or a respectful one. Don't irritate them like throwing the notifications every 10 or every 1 hour. But just one time and respectful one, so that if they want, then they can. If they don't, then that is also okay. And make tires relatable. And you have to celebrate the milestone publicly, because you have to let them know that the things are working. You aren't alone, and there are other people who want to support the project and the campaign. So also the last thing which a lot of folks don't do, but very important, is talk to your peers. So we learned from KDE and other peers that how you can do the fundraising. We took inspirations from their websites and their campaign. So we have to share the fundraising playbooks, what worked, what didn't, what were the challenges, like something we are doing right now. So this will only help all the projects better, and this is the way how you can progress. And yeah, thank you. So if you want to become a friend of Genome today, you can scan this link, and you can see the tires or the pricings, and yeah, it is all your choice if you want to support. So that is all I want to say. Thank you.
No? Okay. Thanks, Aditya.
If there is any other questions, I am just in the booth.
Okay. Thank you. Yeah. Thank you. So our next speaker is Shripath. Shripath, that's right, isn't it? Yeah, please go ahead. Yeah.
So hi everyone. This is Sripat. I work as a assistant professor in KL University. Apart from that, I run a free software community in our university called KL GNU Linux User Group, and also I'm part of Free Software Movement of India and AP's chapter called Svecha. So today I'll be talking about how we build communities to empower students, engineering students, into contributors of open source. The way we started, at least in India or in the Andhra Pradesh state of India, there are people who don't even know what open source is. So that is our first barrier to cross. So we advocate free software, we advocate about what open source is, and we tell that there are a lot of tools that the people are using are already open source. The biggest and the final problem is there are many people who are users of open source and they don't contribute back. So we take that as a point, we tell the students and make sure they also contribute back to the tech and make tech better. So that is, with that as a motto, we run communities called GLUGs, GNU Linux User Groups, and I'll share our story of what we did at KL University. It is one GLUG that we run. So this has been run since 15 years. So all the 15 years we are advocating free software in all means possible. There is a blend of academicians and students who are working together to run this. So one of the project that we did was we built a custom distro for our campus with all the tools that are used academically across. So we transformed all the labs in our university into Linux run or open source run labs, and we enable students to develop the lab manuals and all using free software, and we brought that into academics. And there are many other things that we did into academics. We self-hosted GitLab on our campus server, and all the student projects, all the final year projects and the third year student projects are published as open source. So every student will maintain a Git repo. They will publish their projects into open source. That is one of the policy level decisions that we have taken as a university. And there we introduced some courses called open source engineering. So where we teach the fundamentals of starting from installation of Linux to contribution to an open source. The outcomes of that course will be raising few pull requests to an existing open source repository. So we set a benchmark like the repo should at least have 1,000 commits. So that is the outcome that the student have to get his grade, his or her grade. That is a course, and we installed all the FOSS tools in the labs, and we run something called social internships. So social internships will happen during summer of between every year, May, June of every year. The students go to their homes, they contribute to tech. Not only tech, they also contribute to Wiki, OpenStreetMap, and all the open projects that are available. And you can see there are students interacting with villagers, enabling tech, and also using certain systems like Debian Edu and FreedomBox project. We empowered villages, rural places of Andhra Pradesh to enable networking in the villages, and those are the projects that we do in the campus and also in the ground. So there are few things that we did as KL GLUG. One is we started contributing to open source data sets, the voice samples, the cityscaping. The students use OpenStreetMap, students use Mapillary project. While they're traveling to home, they'll capture all the images, they upload it to the open data sets, and also they come back, they run datathons, they do the annotations and releases as open data sets. So that is Svecha, Gontuka, that is voice data, that voice corpus that we are trying to build. We went to different people in our state, because Telugu language have a lot of slangs in our state itself. So we meet a lot of people, gathered a lot of slangs, and we are building a data set, building a corpus. And as a part of lab, we built ESP32 based open hardware. So that is the hardware that is being used in the electronic labs. The students are build these devices, and those are being used as the tools to run the labs. And campus automation projects, food ordering systems in the campus, and Moodle LMS in the campus are run by the students and maintained by this team. And not just that, we run outreach in all means possible. We run install fests. Whenever a college fest or university fest happens, we set up stalls. We ask people to come install Linux in their machines and fix their issues. And we set up advocacy stalls. We run Wikipedia clubs. We run OpenStreetMap club. And we advocate FOSS to kids. We use Debian Edu as tool to go to government schools, public schools. We teach open source tools to the school kids as well. And there are few other ways that we are trying to build this culture. So we are running Freedom Fest. We run something called Freedom Fest. So it's a large gathering where we run different sessions on all the free software tools that are available. All the people across the state come, and Hacktoberfest that happens in October, everyone. We enable students to contribute, participate actively and contribute to Hacktoberfest. We do the localization activity. So localization, we translate a lot of softwares into our local language, Telugu, which is in Telugu, or Hindi, or whatever regional language the kids are from. We ask the students, these are all the part of outcomes that they have to go through. We run sprints, boot camps, Google Summer of Code. We encourage students to contribute to open source. We ask them to apply for Google Summer of Code, Outreachy. Couple of students got it as well. And in this entire process, to make this happen, this was all possible because of the role of a lot of communities which play around. So free software communities that are in Andhra Pradesh and India, like Swechha is where I work from, and Free Software Movement of India, and different GLUGs. So we established GLUGs in every college. So all the GLUGs collaborate with each other. They do cross collaboration projects. They work together and they share knowledge. They go to different colleges and spread the sessions. So this is the kind of community culture that we are trying to build in our state. And alumni is the students who pass out of the college and still work in different communities or companies around. They come back, they share their knowledge, they build the, they strengthen the communities and work around. So considering the last 3 years of impact that we created, so those are some numbers that we are able to come around with. We reached to free software advocacy to almost 30,000 students across our state through Freedom Fest, hackathons, lot of events, and 2,000 plus open source projects. All the mini projects to the major projects are published as open source, and there are 1,000 plus PRs which are merged. They are contributing to the existing projects, and 10,000 plus data sets changes in the OpenStreetMap. So we run mapathons. We encourage students to stay at home, map the places around. So like I said, in an activity called social internship, the students stay in their homes during summer. The entire task that they have to do for the 2 weeks is they have to map the village and the villages around. They have to identify every tree to every dustbin to every home. They have to put it on OpenStreetMap, and along with that they have to write articles about their village history in Wikipedia. So these are the outcomes. These are the outcomes that we put so that the students are contributing to the open source and localization of tools. And there are millions of voice samples and open data samples that we created so far. So this is the impact that we created, and thank you.
design. Right. So your university has open source by design, and I think it's very inspiring. And maybe you should your university should host the next FOSSASIA.
Where are you based? In which part of Andhra Pradesh? Vijayawada. Okay.
We'd love to do that.
Yeah. It's next to the ocean, isn't it? Yeah. Okay, so let me see. What's the time now?
So we have a book called Sharing a Moral Imperative. It is a collective of articles on free software, knowledge commons, and digital rights. So if you are interested, you can take a copy. We'll put it in near the Devin stall.
Okay, our next speaker is Naruhiko. Is he here? Okay, yeah. Yeah, you still have some time, so you can set up. Yeah. So we'll start at 11:55. Okay. Hello. Yeah, thank you. Got it. Yeah. So our next topic is about burnout and how to stay healthy. Okay, so you can rest for a bit. We still have like another 5 minutes. But I mean, if you want to generally ask something, please go ahead. Yeah. Yeah. Okay. Or if you want to start, please, you can start. Yeah.
I think we should start, like, because there might be other people. Is it time yet? Sorry.
It's 11:55. Supposed to start at 11.
We should wait for time because other people.
Okay. Sure. Okay. Okay. Sorry. No. I mean, I'm saying like, if you want to share something else about Japan or. Yeah. Why should we go to Japan?
I'm from Japan, so we have a booth, small booth from Japan, looking for the Raspberry Pi 500 plus and automotive grade Linux or something else. Please stop by the booth about this. And today's topic is not a technical issue, but I think this is a very important topic about to sharing. So that's why I'm stand here. And so to be honest, my English is not so good. So I prepared a slide.
Okay.
How can I say? Slide note. But this is a PDF, so my slide note is totally gone. So I have to talk without slide note. It is my challenge.
Okay.
Anyway, so please give me a bit. So I feel a bit nervous.
Daijoubu.
Thank you.
My pen right.
Anyway, so could you take my photo?
Oh yeah, please. Yeah, sure. So you are from Tokyo, are you?
Yes.
Yeah. Okay. Nice. Okay, let me take with everyone. Okay. Yeah.
Perfect.
Thank you.
Thank you.
Anybody wants to ask questions about Tokyo or Japan?
And don't ask me any anime or manga because I'm far from anime and manga. But so I know. So every people imagine about anime and manga about about Japan.
Japan, yes. Yeah,
It's a very good culture of the Japanese. But so I'm a bit far from this.
Yeah. I will tell you about the. They used to have this event called bar camps in Bangkok. I think you attended. Did you attend some? And the number one topic ever in Bangkok bar camp was, can you guess? How to date a Japanese girl. It was the number one topic. The whole classroom was occupied. Nobody was in the other rooms. But it was a very technical topic because the girl who did this, she talked about like the distribution curve. Because I think Bangkok is supposed to have the highest number of single Japanese girls outside of Japan. Okay, we have another 2 minutes.
Next to the Tokyo,
Airport,
you know the Narita Airport.
Yes.
My home is very close to the Narita Airport.
Okay, nice. Yeah. I'm running out of questions about Japan. Anybody else? I lived in Meguro. Yeah.
So actually, not a question, but a comment. The reason that I'm interested in this is a space that I've also been working in for quite a while.
Okay.
And I realized that one of the possible answers is using game elements.
Okay.
To keep people to keep it bigger, not games as in the points, badges, and leaderboard.
Yeah.
But actually coming up with a good structure of rules and incentives.
Okay.
So that people continue to be engaged without actually feeling burnout, because it draws a good game element to sort of draw you in naturally without the burnout part. So so it's something that we've been working on for I think the last year or so.
Okay.
And it looks very promising.
Okay. Are you documenting it somewhere or like are you?
I gave a talk at the Inner Source Summit, but then if people want to discuss game elements, I am around. I have my slides.
Okay.
So I'm happy to whip them up and have a discussion.
Okay, let's see if we don't have any speakers show up, then I'll invite you.
Yes, why not?
Okay, thank you. Yeah. Okay, you can start. It's 11:55. Yeah.
Okay.
Yeah.
Let me start. My talk is from burnout to burns, embracing user participation in open source. This is my personal story, and I hope you or some of you take something from my talk. I'm a security engineer in Japan from Shift Security Incorporated, but my talk is not as a security guy, but one of the long-term open source enthusiasts. Okay, let's go. Why this talk? I think open source encourage people. This is the passionate people, but no one. Very few people talk about burnout. Yeah, this is we really talk about it. But in COVID-19, lots of people disappeared without anything talks. So this is so very typical issue, I think. So I want to share my story, and so because so I'm one of them. For COVID-19, I feel exhausted and quit all of the open source activity. But now I'm here. So this is my story. Step down from the open source community and then back to the open source community now. So my story, I've been LibreOffice community. I had been in the LibreOffice community mainly 10 years ago, 10 years or latest. I forgot the actually, but mostly in the translation work or local community organization. I mean some kind of the event. Or sometimes the global event, we say LibreOffice Asia Summit or something. And but COVID-19 stopped in-person event, so I feel so no casual talk. So no casual talk and no chairs, no casual dinner or something like that. So everyone is gone, and small tension accumulate. Then I feel I'm really exhausted about the people. And I'm a LibreOffice community from LibreOffice community. LibreOffice community is now it's facing the very difficult situation. One of the big ecosystem company has a strong enough, but so others. So this is a kind of the tension with the ecosystem company and individual committers. So long, very long email thread we have, but my English is not so good, so I cannot understand anything, but I feel tension is too high. That's why I feel exhausted, and I stepped down from the LibreOffice community, I did not leave because of code. I left because I felt alone. Why burnout happens in open source open source software or open source community? One is too much work, no ending issues. Right now, so we have AI strop. I mean that someone send a maybe pull request with AI. So developer is exhausted to handle these kinds of the issues, and strong responsibility. For example, if I stop the commitment, something stopped, or such kind of the strong responsibility is a very common cause of the burnout. And how to say, I need to break. So so burnout is not weakness. It is some kind of strong responsibility. Yeah. And the hard part is how coming back. I still cared about open source, but I didn't know how to return. But it was, for example, I was afraid of expectations. I mean, for example, if I go back to the community, I wonder how I can, as a previous, I can work as a previous. So, for example, so I worked a lot of things about the translations or organize event or something like that. But if I go back, you can do other same position or something like that. So this is my heart. So this idea stopped me. But so lucky to say, I still have a lot of friends in open source world. Not only Japan, but also worldwide. So I started to just meet to the friends, to attend the event, to just meet to friend, and then I supported the event organizer. He's also a friend, and something. This kind of the small participation is very good for me. So I can, so for example, I attend the FOSSASIA 2024 in Singapore. And this is just my participation. I don't have a talk about this, but nowadays, so I can talk with, oh, each time is okay? Anyway, so this is how can I go back. So I want to share the idea of Yuru participation. Yuru is a Japanese word. This is a loose or low pressure or gentle in Japanese. It means no obligation, small contribution is okay. Small contributions are okay. And no fixed schedule. Just being there is participation. It so very loose participation is important to the open source community. Why your participation works? It's a low pressure. People stay longer. Because of the low pressure, people stay longer. And small action still help. I mean, I show some sorry. Anyway, people feel more welcome. Light participation is still real participation. For example, fix a small typo in the global typo or Japanese local typo or something. Leave a comment in issue tracker. I have retrieved this issue or something. Attend the community meeting casually. Just attend. Not doing something more. And contribute to translation or documentation. Join low pressure group. I had a translation cafe. Just being here and doing translation something, it's okay. Such kind of low pressure group is perfectly works well. And share knowledge on your own experience as me. Okay, and benefit of the community is the lower entry barrier, not only the comeback people, just so casual committer or something, and less dependence or human maintenance. This kind of small works helps the core contributors. So, and safer atmosphere. We provide a safer atmosphere, and yeah. So, message those who are tired. Burnout is common, not only your problem. So, it's not shameful. Your participation helps helps you, and of course you can return anytime. If you feel tired, you have a right to take a rest. But we are welcome to come back to here. This is your place. So this is my message. Key takeaways. Burnout is common and understandable. Recovery begins with gentle participation. Communities must widen the definition of contribution, and your participation benefits everyone. You can return at your pace in your way. Oh, maybe finish? No? Okay. Thank you for listening. Any question, comment, or something?
Yeah, hi. Thanks for your speech, Naruhiko. So my name is Melvin. So I actually also have my own open source community called Your First Open Source Project, but I'm the only sole maintainer. So in your experience having your own community, having this Euro participation, how has it helped like remove any bottlenecks? Because I'm the sole maintainer of my project and I feel that I'm having burnout as well. So you having this Euro participation, how do you introduce your members to this, and has it actually reduced the bottleneck of having like a few maintainers for your project?
So it's a bit hard to understand. Anyway, yeah. Your question is so how to.
How do you introduce this concept of Euro participation to your community? That's the first question.
Yeah. Maybe so. I will have a talk in the open source LibreOffice global conference or something like that. So I want to share my story not only here but also any other place. And I also something talk about my membership committee. Document Foundation membership committee to apply reapply is very important to the Document Foundation background of the LibreOffice community. And sorry. Anyway, yeah. Thank you for a nice comment. So I need to share this kind of the Euro participation idea to the anywhere I want to share. Yeah, thank you.
Thank you. Thanks. Thanks, Nariko. Any other questions? Okay. Yeah. Oh, you have a question. Okay. Yeah. Yeah. Yeah.
First of all, thank you for your talk. It's good that you managed to recover from burnout. I've suffered myself. My question is similar to the previous question. Do you have any thoughts on how you would apply this to a project that doesn't have a committee, that only has very few developers, a bus factor that's close to 1, and therefore, if you step down, then the project is likely to suffer greatly from you pulling back. So I know this is not your setting, but do you have any ideas of what we can do, the lone developers, to apply this to our use case?
Okay, so I think I have to start some kind of the small casual meetup in Japanese community, and maybe so my steps should be start a small and then wider in global. I mean so. I work on the LibreOffice Japanese community, so I started the LibreOffice Japanese community. I mean, for example, I attend some kind of the online event to translate LibreOffice and share my experience about that. Yeah.
Okay, thank you.
Thank you. Just hang on. I just want to check if the next speaker is here. Antoine. Oh, okay. You don't mind if we take up like 2 more minutes?
I just have a joke.
Yeah, okay.
So actually they say that open source maintenance is like goodwill hunting in reverse. In goodwill hunting, you are a janitor and end up as a genius. In open source maintenance, you are start off as a genius and end up as a janitor.
Thank you.
Thank you.
Sorry.
Thanks. Okay.
Thank you.
Thanks, Narika. Yeah, you can come here. Thank you. Yeah. Do you need? I see your hand is. Yeah.
Thank you.
Yeah, there are slides here. Just check in this laptop if you see the slides. But I do have an laptop.
That's okay. Thank you. Okay, that's the one. Here we go. One, two. Here we go. Finally. Good afternoon. My name is Antoine Martin, and I am the maintainer of the Expra open source project, and I am somewhat of an expert at failing. This talk is my way of putting a positive spin on the fact that the vast majority of the projects that I have been involved have failed. How do I skip? Yep. Yeah, so failing is both common and painful. I'm sure you've all experienced this. Well, I hope, yeah, because I certainly have. And let's see what we can learn from this. So I have here some examples of oh, there's something missing.
Okay, this slide is blank.
Okay, that's okay. So we can skip this one. Failing is common. We all know the examples. It doesn't matter what you do, you can fail. You can be right, you can do the best you can have the best technology and still fail. So I think the best way to deal with it is to accept it, learn from it, and move on. So this slide is a lot of psychobabble. You should really not get psychological advice from a failing software developer, in the same way that you should not get medical advice from your mechanic. So I'm not qualified. All that said, I do believe that what you see here is true, that you should learn from those mistakes by acknowledging them and being true to yourself. That means facing your shortcomings, facing what you should have done different. And like I said earlier, you can still fail even when you do everything right. So it's a difficult one because you have to be able to distinguish when you failed or when someone else failed or some other reason why things failed. And the main thing that gets in the way of all this is your ego. Your ego will try to protect your own image. So you will reject anything that comes your way that threatens your ego. And that's, for me, the most important lesson here today is to learn how to set aside your ego and grow from this process. So the next one I think is self-explanatory. This is definitely true for me. Perhaps you're one of the lucky ones and you can learn from the theory or the practice. But personally, I need to make those mistakes to feel the pain, and then sometimes I learn from it. My GitHub bio says that I like to take things apart and sometimes put it back together successfully. This is why I do open source. I want to know how things work, or why they don't. So moving on to the Expra project. Has anyone here ever heard of it? No one? Really? Wow. Used it before? No, certainly not. So we're going to look at some issues that I've experienced in the project, and we'll first start with an overview of what it does and how it does it. And sorry, that's okay. So this is what it looks like, and for most of you, this will look like a normal Windows 11 desktop with a Firefox window and an extern behind it. Okay, the extern may look slightly out of place. But there are a few clues on there that these are not regular Microsoft Windows. If you look at the Firefox icon on the top left, it's got a little X in it. And also here in the taskbar, same for the extern. And that's because these windows are running somewhere else and being forwarded to the desktop as individual windows. That's one of the most important features of what Expert does. So we do have some other, things we can do to make it clearer that these windows aren't your usual windows. We can have watermarks, and if you know of CubeOS, we can use decorations on those windows, have borders on them, so you can more easily identify which windows are regular windows and which windows are being forwarded from somewhere else. Next one, please. So this has been generated by an AI, so I believe it's mostly correct. It presents what the Express server does, and did you see what I just did there? If it's wrong, it's not me, it's the AI, right? So on the left, we have the server, and on the right, we have the client. In the middle is the network connection between them. And the server will virtualize everything that the client needs to interact with those applications. So it will have a virtual display matching what the client has. It will have a virtual keyboard matching what the client has, and so on and so forth. And in between, the client server communicate through any of these transports that we have here. So you can, through the same port, and this is a pretty cool feature of the Express server, the same port can talk all of these protocols, except for KIC, which is UDP, but otherwise you can have a single port and you can connect to that port with TCP, SSL, WebSockets, secure WebSockets, what else, VNC, SSH, so you can use a normal SSH client and connect to that one TCP port and connect your client that way. So the big difficulty is in synchronizing the virtual devices, the virtual environment on the left with the physical environment of your desktop on the right. So the next slide, it may look like I'm bragging about my contributions, but this is more about the talk that we just heard previously. It's about burnout. And yeah, so I do believe that as an open source maintainer, you should respond to queries, questions, pull requests, tickets, and you should do it not on your terms, but on your users' terms. Maybe they don't have time for your project. Maybe they only have weekends. Maybe they live in a completely different time zone, and you need to be responsive. The problem with that is this. Where's my life? So it's a question of finding the balance, and like Ogasawa-san, I have had some burnouts because I couldn't find the right balance between helping people and being good to myself. Difficult one. There is an upside, like I say here. I do have flexibility that most people don't have. It's just that I'm not very good at managing it. Yeah, so users and contributors to the project are essential to the health of your project, but don't let that damage your own health. Like it says here, find the right balance. I don't have the answer. All I can tell you is I failed to find it. So this one, how are we doing for time?
We have another 5 minutes.
Oh, okay, skip.
Yeah, 5 minutes.
Okay. Skip. Skip. And skip. Okay, let's do this one. This one is interesting. So you've probably heard this before. People say Python is slow. And because Xpra is mostly written in Python, I thought, well, it must be true. Maybe Xpra is slow because Python is slow. And, you know, there's problems with Python, the global interpreter lock, and multi-threading is not very good, and it's interpreted, so it's got to be slow, right? That's what everyone says. If everyone says it, it must be true. And so I wanted to find out what I should do about it, and all the options were on the table. Should I rewrite the whole thing? That was an option. You know, you could just translate it and rewrite, or should I find a way to make it go faster? And it turns out that I investigated it, and there is no issue, or at least nothing measurable. 95% of the CPU time that the server and most of the client will spend doing all that forwarding back and forth of mostly pixels is spent in heavily optimized libraries like Turbo JPEG, X264, libvpx, and so on. And they had some very smart people optimizing it in handwritten assembly for 20 years by hand, writing up codes. And so the idea that you can do better by optimizing the remaining 5% is ludicrous. And so I ended up realizing that there was better ways of spending my time than trying to compete with what these guys are doing. So yeah, the conclusion is don't necessarily, I'm not saying that people are wrong when they're saying that Python is slow. They're not. Python is slow. But does it matter for your use case? It didn't for us. But obviously I didn't learn, because a few years later, I thought, well, people keep saying it's slow. Surely they have a point. And so I investigated it again. And I thought, well, maybe I got it wrong. Maybe I tested wrong. Maybe there's another way of doing things that will show that Python is slow. And I thought, well, again, maybe not rewrite, but maybe I can convert the whole code base from Python to C using Cython, because we had type annotations, we had much better test coverage, everything was in better shape to do this. I thought, well, let's have a go and see how much faster it's going to be by compiling to C. And, well, the compile time went up 800%. Is it on here? Yes. But apart from that, nothing. The performance of the system as a whole stayed the same. So again, I failed to learn that lesson. I knew that it was probably not going to help, but I did it anyway. And it wasn't all wasted, because by doing this, we improved the code base, and this is now part of our CI tests. The type hints are being validated using this framework of Cython. So it's not a complete waste of time. Right, so this one, sometimes in the early 2010s, I decided to see if I could write some more clients for the Express server, because why not? And most of them failed. So we had a Java Android client in 2013, and that was a total failure. The fact is, I'm just not good enough for this. I'm okay with that. There are better ones now, but this one was a complete dead end. Also in 2013, a Qt client, again, complete failure. It was just too messy, and our code was too dependent on GTK, so that didn't work out. But then after that, 2015, an HTML5 client, which I did as a proof of concept. And that one ended up being tremendously successful, to the point that some customers of our sponsors saw it from the corner of their eye and decided, drop everything. This is what we want. So that was a major, major win, and it's still heavily used today. And we even have clones and rewrites, including a new one that came out just yesterday. I got a message telling me, check this out, there's a new client, and it came out literally yesterday. And also in 2024, I made some Qt6, a revival of the Qt port, SDL and TK. So these are just lightweight proof of concept, not very useful on their own. 2025, I made an attempt at Rust, because Rust is so popular and it's supposed to be safe and fast. So I thought, well, why not see what we can do with it? And it turns out that it's just a very, very bad fit for what we do in Expra. I'm not trying to diss Rust at all. In fact, I believe a lot more libraries should be written in Rust. It just happens that for what we do, it's just not a good fit. And finally, 2026, I've started work on a new client to replace GTK with native APIs for Microsoft Windows. So, yeah, the failure here, like it says, I spent so much time writing code that just ended up being thrown away. And I think that's okay. The one that did survive, the HTML5 client, is being used by, I don't know how many, because I don't keep track, but lots and lots of people use it every day. And that was just a proof of concept when it started out. So it's worth it. We're going to skip that. Skip to... can I do another 2 minutes on this?
Yeah, sure.
Sure. So, I don't know if you can see this. Yeah, it's okay. So the main job of the Express server is to message the clients with all the screen updates. So when we had Firefox shown on that desktop, obviously Firefox is being rendered on the server, and we need to shift those pixels to the clients. How are we going to do this? Traditionally, remote desktop solutions had their own thing. So VNC had hex style and lots of really old encodings that didn't really work very well. Fortunately, because XPRA is new, we didn't have the constraints of fitting with a given protocol, so we could add whatever was around. And so this is what we have. And as you can see, some of them are super fast, like the top ones, RGB and RGB-LZ4. These ones don't compress at all. It's just we send the pixels in plain RGB, we throw them at the client, and that's super fast. The problem with that is, if you're trying to send, say, 4K 60 Hertz to your clients, well, your DisplayPort cable that handles this does about, I think, 12 gigabits per second. And very few of us, does anyone here have 12 gigabits per second network connection anywhere? I don't. So obviously, that's not going to work if you're trying to stream 4K 60 video. At the other end, we do have AV1, which is very, very good at compressing. And so this one you can use for 4K 60. So why do we have all these other ones in the middle? Well, it's all about choosing the right one. And this is a job for the Express server. It's the subject of all the slides which you can download, all the previous slides and all the few following it. It's making the right decision based on a number of factors. And we'll just go through this quickly if you have time. Sure. Okay, so given a window that you need to send to the client, you need to choose from that list which ones are going to be the most suitable to get those pixels to the client quickly. And obviously, you're going to have to choose an encoding that's supported by the client. And then we use the content type of that window. So if you run an exterm, we need to figure out that it is text, because you don't want to lose quality when you're sending text. So we look up the process ID, then we look up via the system menus what kind of application it is, and we figure out that it's text. And if it's text, we never sacrifice quality. On the other hand, if you have video, say you're running VLC or another media player, then we detect that this is video and we will do completely different compromise. Then we have the state of the window. So obviously, if your window is right on top and full screen, it matters. This is what the user sees. On the other hand, if it's at the bottom of the stack and obscured by something else, it doesn't matter, so we don't send it as quickly. And then the window type, think of a drop-down menu. Well, that one is likely to need lossless. You don't want to have damaged pixels on there. On the other hand, if you have a really big window with, say, pictures, well, then you can sacrifice a little bit of quality there. Then it takes into account the pixel depth, because we support all these numbers you see here. So 8-bit per pixels all the way to 32-bit per pixels. And 32 can be 24 pixels per pixels. 24 bits per pixels plus 8-bit of transparency, or it can be 30 bits of per pixel, that is 10, 10, 10, plus 2 bits of transparency. And so these encodings all have different capabilities. Some of them handle all these formats, very few do, and some of them don't. Then we have the size of the screen update. So a video codec will have a minimum size and a maximum size, which you're unlikely to reach, but you may. And yeah, so we also care about other updates. If there's many updates on the screen, do you want to send all of them individually, or do you want to just group them together? That's the kind of decisions that the engine has to make. And, oh, there's a big one there. So the presence of a video region on screen. So if you have, say, a browser showing YouTube, and you have a video in the corner, well, you want the text of YouTube to be lossless, and you want the video of YouTube to be, well, ideally lossless, but you're probably not going to be able to do that. So you want to sacrifice the video to keep the text clear. And the network conditions. So obviously, if your network connection is struggling and it's deteriorating, then we try to prevent, not make things worse. So we may drop the quality, we may just lower the frame rate just to make sure that we don't deny of service your network connection. We also use the historical compression data, so we know what we sent before and we know what quality we sent before, so we try to take that into account. And then finally, there's the user settings, which we have simplified because every codec has its own way of representing these things. So we've simplified it down to just quality, speed, and frame rate. The auto refresh is accessories. So, finally, I forgot one very important one, the spin up time. GPU encoders are super fast, super efficient. They can give you, 4K 60 without any problems, but they take time to initialize. So that first frame may take 100 milliseconds. That's not acceptable. So we send other updates and then let it spin up, and then when it's ready, we start using it. Why do I talk about this? Because it is a failure. So, like I said, users have a few knobs that they can control, speed and quality and frame rate. And what happens? Well, they select high speed, high quality, high frame rate. And then they come to me and say, hey, it doesn't work. I'm not getting high speed, high quality, high frame rate. And then I say, well, do you have 12 gigabits per second of network connection? They go, of course I don't. And the failure here is I fail to manage their expectations. I give them controls that they can use without explaining that these are all about compromise. You want to sacrifice something. You can't just have everything and defeat the laws of physics. Unfortunately, people refuse to accept that the engine knows better than them, and they will come to me and say, oh, I want to use PNG. I like PNG, it's lossless, and I want lossless text. And that's a terrible idea. The engine knows what's best. If you type just one character into a next term, you don't want to use PNG. That's going to be, I think, 6 pixels wide by 13 pixels up. That's, I believe, 78 pixels. Say it's 32 bits. You're talking about 250 bytes. The PNG header will be bigger than that. So don't use PNG. Let the engine decide. But people invariably think they know best. So they'll be selecting video because they want to use the GPU encoder, and they'll disable everything else because I want video. That's what I want. I have a GPU. I've paid for it. I want to use it. Well, it turns out, like I said, you need to give time to the GPU to warm up. And if you don't have alternatives to the GPU, it's not going to have time to warm up, and it's going to stutter. And then they'll be coming to me saying, oh, your solution doesn't work very well. I'm getting stutters. And then I'll be asking for, go back and forth, and we'll discuss it. And eventually I'll find that they disabled everything else. They want to use the GPU without understanding that you need more than just the GPU to achieve what they're trying to achieve. Yeah, so initially, I believed that I failed to document, that's what you needed to do to make it work. And so I wrote lots of documentation and wikis and manual pages and so on. Didn't help. And the more I started talking about encoding, saying, oh, don't choose an encoding, people started thinking, oh, there's an encoding. I should be looking into this and choosing one. No, I said, don't choose one. But the more I said, don't choose one, the more people got into their heads that this was something they needed to learn about, which is totally not the case. So the lesson here is, I don't know. Sorry, I don't know. How much time do we have?
We are running out of time.
We have run out of time.
The next thing is lunch, so.
You're hungry? I can see you're hungry. You're ready to go. Right, we can skip to the end then.
Yeah. I think the Q&A, if you guys want to go for lunch, you can go. If you have questions, please, you can stay behind.
Happy failing.
So
any questions?
Yeah.
Wow. Hungry people.
Okay, thank you. Thank you, John. Yeah. Thanks, everyone, for joining session.
Exactly what I'm talking about.
Sorry.
Right. So for today, to kick us off, we have Mr. Harish Pillay from Singapore. Right. So it's only 15 minutes, so we'll give all the time to him. Right. And the topic is on open source tools to build next generation chip designers. Okay, so let's hear from Mr. Pillay.
All right, thank you. Good afternoon, everybody, and I hope your lunch was okay. If it's not okay, too bad. All right. So my name is Harish. I have been in this tech space for a very, very long time, and I've done. Oh, sorry, your camera person. You have to keep moving. No, I know. So you manually track me. All right, good. At least you won't fall asleep. I heard you, Mishari. But welcome. So thank you for attending this short 15 minutes talk. So I entitled this, contrary to what was in the agenda, I'm calling it a chip designer, using open source tools to build the next generation of chip makers. That's really what I'm trying to help achieve. So a bit of myself, I'm an electrical engineer by training. I did my graduate degrees in electrical and computer engineering. And as you can see here on the right hand side is it's a picture of the first chip I ever designed. This is in 1989. I know none of you were born then. Other than you and I, yes. And Mishari, yeah, oh, okay, all right.
Hello, test.
Is the mic, which mic? Change mics. All right, is this better? Yes. Okay. All right, so this is a chip I designed. It's a chip that does 2-bit by 2-bit multiplication in parallel. That's what this is. This was a class that I was taking called, what's it called? EE something or other. EE 518 in the winter term of 1990, which is December 8, 1989, and so on. Anyway, the point about this is to do this particular design, which I kind of expanded out. This is actually a very large paper. I had to do multiple copies to make sure I can fit into a slide. So this has got the necessary components for 2 bits by 2 bits to do the computation, to do the parallel multiplication. That's really what this is. So you can pump in through. If you look at it, it doesn't look like anything that is immediately obvious unless you keep looking at circuits of this nature in a chip. This is what you see in all those chips that you have, in all the devices that you have. Now the key message here is that this is not difficult to do. But back in those days, it was a very, very expensive process because it cost a lot of money. The tools that you needed, the software you needed to use and so on was very, very expensive and so on. But the purpose of this talk is to say that world has moved on. Almost now 35, 40 years later. We now have a way to address the problem. The problem here, as you can see, the tools were expensive. There was this need to sign an NDA, a non-disclosure agreement with the manufacturers of these tools. They say, oh, you cannot tell other people how you did it or how the tools work and so on and so forth, which means you and I as an individual, okay, we may sign, but then after that I can't share it out. And the last point here is long timelines because it costs a lot to acquire and then to design the hardware, again, it was a lot slower. The design that I showed you earlier, I had to do the final testing. It took me 72 hours to run on an HP machine, HP Unix machine, sitting in the university. 72 hours, so from Friday, Saturday, Sunday, put stickers on the monitor, say do not turn this thing off, so that by Monday morning, I know hopefully it's successfully tested, and then and only then can I send it for fabrication. 72 hours to do a 2x2 multiplier. That's a very, very long process. So these were some of the constraints that have been, and this is the same set of constraints that have been around for a very long time. So what goes into getting a chip made? Okay, there are a few steps. Now, all of you, I assume, have written a piece of software. Even if you did a introductory class in software design or writing Python for that matter, you have done your Hello World program. So what were the steps? I want you to link the steps that you went through to what you have up there. The first step is identify the specification. What is it that you want to build? What code that you want to write? So in this case, what hardware do you want to build? What is the problem you're trying to solve? First step, get the specification. Before doing anything else, write it down or whatever. After that, then you start doing the chip design, the layouts. It's called logic design. There are two types of circuits that you need to make. One is a set of circuits that's called gates. That means like AND gates, NOR gates. If you know this, you understand the terms. If you don't know it, it's a time to go and learn about it. All right? It's logic gates. And the other one is memory. So everything that we do, every piece of hardware, every piece of software, your cameras, your phones and everything has got gates, has got memory. These two work together. And all of those go into the logic design. From the logic design, you create what is called a net list. I need to know, okay, all the components that make up my particular design. And the HDL here stands for Hardware Description Language, HDL, because with the HDL, now we have a common way for designers, chip designers, to talk to each other. Just like if you're a Python code writer, you write Python code, you can share with another person because there's a certain syntax, certain style, and so on and so forth. So same idea applies. Once you get that done, you hand off to somebody else who does actual placement on a chip. And that's what this is called placement. You place your circuit on a design so that this then gets tested, validated, signed off, and then it goes to the foundry, the chip semiconductor foundry for manufacturing. These are the steps. So if you take this as an example, here you have an example of the HDL language. This particular one on the right-hand side is taken from Wikipedia. I just want to use publicly available information. So this is trying to do what is known as a flip-flop. A flip-flop, if you have done chip designs or circuit, a flip-flop, you try to, like a clock, on, off, and you have a certain rhythm to it. This is how you define a flip-flop. The code is this in HDL. So there are many of these kinds of code out there that allows people to just take a flip-flop as an example, like a library, like Python libraries and all. There are all these libraries. You can take that and then go ahead and create your designs. So this is an example of how, on the right-hand side is a software analogy. If you're writing Python code, C code, whatever you're doing, what's the equivalent from a hardware perspective? So on the right-hand side, source code, Python, JS, you write your design. And the tool you can use is something called, as an example here, TL Verilog, and so on. There are many of these out there. Then synthesis. This is like you compile your program. That's called synthesis in the hardware space, compiling your program. And then what is known as place and route. There are two open source projects, OpenRoad and OpenLane. This is like your linker to build your program. So if you wrote in C, then you do the compiling, and then you do the linking, and then finally your application that you can run. Okay, that's the analogy there. The next one called layout. This is to do physical verification that this actually does 1 + 1 and not something else. You physically test it. This is like your debugger. When you want to debug your program, something is wrong. Hey, how come it's not doing the right numbers, right? That's exactly what you have. And then the final bit here, this is where the difference is. The final layout before this goes out to the fab. The fab or fabricator, this is a company that runs a business that has got fabs. Like a very well-known example is something that is based in Taiwan. Have you heard of that, an organization called TSMC? Taiwan Semiconductor Manufacturing Corporation. They manufacture, they are the foundry. So you create all this wonderful stuff, then you send it to the foundry. But before you go to the foundry, there are certain rules you have to follow. Part of the problem is those rules have NDAs associated with it, non-disclosure. I can't tell you, oh, I am TSMC. You want to send it to me, I'll give you the document, You have to sign an NDA before you can send it across. You and I, we are not going to sign NDAs, right? From an open source point of view, that's just not going to work. So work has happened that now we have, it's an example here, a lot of open, what is called PDKs. The NDA you're signing is for a document. It's called a process design document. And the PDKs today have become open sourced. Not all of the manufacturers do it. Some of them do. And increasingly we have, one of the earliest ones was someone called Skywater. Google worked with them to create an open PDK. So all of us here can design our circuit, use the Skywater PDK, generate the output that then send to Skywater for manufacturing. That's all that was supposed to do. And today we have a lot more opportunities to do this as an end user. Now, it is still expensive. I'm not saying it's free of charge. It's still expensive. So this is an example of how you handle the expense. That big circle there is called a wafer. This is a big disk of a silicon, of silicon, onto which you put your circuit designs. One wafer, I give you some numbers. One wafer typically costs $10,000 to put circuits on, 10,000. But one wafer can have 1,000, maybe 1,500 individual circuits. So if there are 1,000 of us here, each of us have our own circuits. We can collectively put it all into that one wafer, and each one pays $100. So that's how we share the cost for the wafer. So in order to do that, a lot of the foundries didn't allow that kind of sharing. But because of this change, we now have the opportunity to create new designers that can quickly get something going. Otherwise, it's talking about thousands of dollars in investment before you know whether your circuit works or not. So this is doing, in a way, what 3D printing has been able to do. So it's the easiest analogy is 3D printing. So these are examples of different design from whoever it is. All right. So there's one organization called Tiny Tapeout. They make it available for anybody to build. Let me get this. Let me just go back here. To anybody to build for sub $500 per design. But if there's a lot more people on the one die, it becomes cheaper. So if the circuits are very interesting, you can have as many as you want to do. Each of these circuits is maybe $100, $200 or something like that. But the only challenge here is it takes some time for it to come back. So once you send it to the manufacturer, it takes maybe 3 months. And then it comes back to you. And then now you can say, oh, now I've got my chip. What do I do with it? Test it, make sure it works. And if it is a product that you want to ship, it becomes an opportunity for you to create more of this so that you can incorporate into whatever you're going to build. Okay? So that's this part here. This process is called MPW, which is called multi-project wafer. So each one is one project from somebody. So multiple projects on one wafer, MPWs. Okay? Now, this is an example of how you can do today, build your own CPU. So RISC-V is a CPU architecture. It's called an instruction set ISA. This is a completely free architecture that you can implement for yourself. Free in the sense that this is on a Creative Commons license. It's not on a GPL, it's on a Creative Commons license. What is more important here is that you can now go ahead and build your own CPU, unlike using ARM or x86 or any of the others, because then you have to pay licensing fee and all kinds of stuff. Today you can do that. And almost every device that you find, the very tiny ones, they're all running RISC-V in it. Now you can design for yourself using the same tools. Okay? So Tiny Tapeout is an example of an organization that provides this opportunity for you to create chips very quickly. So here are some resources that are of interest. I just want to point out the one with the big elephant in the room. The elephant in the room there is all about AI in chip design. Is it possible? So I would encourage you to read this document, this article from ACM. It's all about chip design using AI tools. It works, it doesn't work, and so on. And I would just want to also highlight there's a lot of people doing this work globally in around Libre PDKs, so that you can have the opportunity to build your own stuff along the way. Let me just wrap up here with one very important thing. ASEAN now has initiated a process that we're going to create a ASEAN-wide semiconductor design capability to incorporate RISC-V as the official architecture for ASEAN. Now, whether it will succeed or not, I have no idea. But at least ASEAN is trying to do something. And I'm glad to say that I was part of the process to force the issue. Now, whether it will be successful, I have no idea. And with that, I will just end here. So if you want to connect to me, my email address is there, and let's have a conversation. So thank you very much.
Okay, thank you, Mr. Harris. Right, so feel free to engage him after this session. He'll be around. And due to, in the interest of time, we'll move on to the next speaker, who is already here. So, yep. So that will be Miss Joy Chen. Are you using? Oh, okay. Is it okay if she wants to use her own laptop? Okay, we might take a bit of time. She wants to use her own laptop. Is it okay?
Okay.
So you need to connect. Okay.3:05，他们3:05。好，可以用。
开着吧。
啊，对。
上班。
开了。
Hello everyone, this is Joy from Deep Computing. Today I'm going to show you the state of the RISC-V web platform, Chromium and Node.js progress. I don't know how many of you guys here. This is not working. Are you?
OK， 这个不知道能不也是。
Okay, it works. Okay, let's continue. So I don't know how many of you guys know about Deep Computing, so let me do a brief introduction. Deep Computing is a startup company focused on RISC-V. We do RISC-V laptops, pads, and we also make some RISC-V powered phone gadgets, toy cars, and balloons. So in 2023, we make the first generation of our own RISC-V laptops. And in 2024, we make the second generation, and it's 8-core, 1.75 gigahertz, which all can run Ubuntu and Fedora. But after doing 2 generations of our own laptops and pads, we realized that for a startup company like us, it takes a lot of time and money to do this. So we decided to partner with Framework. Framework is a company that they make repairable and upgradable products. It also supports multiple ISA, so whether you can use x86, ARM, or RISC-V. So from that, we focus on making RISC-V motherboard for them. That coming out the first generation of the RISC-V motherboard we made for Framework laptop. It's 4-core and 1.5 gigahertz. And then in the same year, in October, we make the second generation. And it has up to 50 TOPS and can run AI locally. And then it's the latest generation. It's 16 cores and has up to 16 TOPS AI, which also supports RVA23 profile. For those who are interested in this product, can come by to our booth in the third floor. Now let me introduce Bruno, a senior developer relations engineer who has been working on bringing Node.js for RISC-V. Bruno maintains the unofficial build for RISC-V 64-bit, providing ready-to-use packages and binaries for Node.js. He could not be here today, but he prepared the following slides to show the current status of Node.js and Chromium on RISC-V. So before we dive into the details, let me explain why this talk covers both Chromium and Node.js. The answer is V8. So V8 is Google's open source JavaScript and WebAssembly engine, all written in C++, and is a heart of Chromium, where it runs JavaScript in the web page, and Node.js, where it runs JavaScript on the server side. So when V8 is ported to RISC-V, both platforms can benefit from that. So let's look about the V8 JIT pipeline on RISC-V. Ignition is a ByteDance interpreter. Sparkplug, the baseline JIT, gives faster startup. And Turbofine, the optimizing JIT, has peak performance. The gap is Megalove, the mid-tier JIT, which is not yet ported to RISC-V. That means there is a performance cliff between the baseline and optimized code. WebAssembly also ports to RISC-V with SIMD mapped to RISC-V vector extensions. So Node.js classifies RISC-V as experimental. That means there's no official binaries on Node.js.org, and test failure does not block release. The good news is upstream issue 2876 was closed as completed in February 2026, so it's now officially recognized. Technically, V8 is well ported to RISC-V. Both Turbofine, the optimizing code, and Sparkplug, the baseline JIT, and WebAssembly also works. Historically, the issue is OpenSSL no ASM build flag, because there is no RISC-V assembly in OpenSSL. But this issue is now resolved in OpenSSL 3.1. So how can we move to Tier 2? We need permanent CI machines in Node.js build pool and committed maintainers. So hardware vendors and community members can help here. Since there is no official Node.js build for RISC-V, so Bruno created the unofficial build project that fills this gap. What makes this project special is that it runs the entire build natively in a real RISC-V hardware, a Banana Pi F3, using 8 core and 15 GB RAMs. This project has already built and released. Node.js 22 is a LTS line, and Node.js 24, the current line. The pipeline is fully automated with a GitHub Actions self-hosted runner, and the runner is the RISC-V machine itself. So how can you download Node.js? First, from GitHub release. Second, use apt repository for Debian and Ubuntu. Third, use RPM repository for Fedora. Everything is GPG signed for security. So here is how the build architecture works. It runs the entire build natively in a real RISC-V hardware, the Banana Pi F3, rather than cross-compilation. The self-hosted runner on Banana Pi 3, it downloads Node.js source and compile with make using Ccache, generate Debian and RPM packages, and create GitHub release with artifacts, and automatically update apt and RPM repositories. So now it's a trade-off. Cross-compilation takes only 30 to 45 minutes, while the code-native builds, the first time without cache, takes 8 to 12 hours. This is the current reality of RISC-V hardware, but with a warmer C cache, the subsequent builds takes only 14 minutes, and we get the crucial benefits of testing in a real RISC-V hardware. So let's look at the full Chromium browser. Like in previous slides, V8 is well ported to RISC-V. But a Chromium browser is much more than a JavaScript engine, and there is no RISC-V bot in Chromium CI system. That means RISC-V build packages will go undetected until community members cache them. Beyond V8, several efforts are needed in specific RISC-V. And all existing Chromium build for RISC-V comes from community efforts. OpenSUSE was the first distribution to build Chromium for RISC-V back in 2021, and OpenOiler port version 100 and 103. And the RISC-V Folks project, they provide CI system that catches RISC-V build breakages. And Xuantie, the Alibaba RISC-V team, contribute to the performance optimizations for RISC-V. So let's look at the real performance numbers. On Speedometer 2.0, the RISC-V machine scores about 9.75, while Raspberry Pi 4 scores about 17 and Pi 5 scores 16.3. So we are roughly half the speed of Pi 4 and 7 times slower than Pi 5. For WebGL, our deep computing DC Roma 2 hits 14 frames per second, while in Firefox it manages only 16 frames per second. That's because Chromium has better GPU accelerations on RISC-V. So how can you contribute to Node.js and Chromium? Download it. If you have RISC-V machines, you run it and test and report to upstream. Second, if you are a hardware vendor or have spare boards, consider sponsoring to the CI machines to the Node.js build port. And you can also use Bruno's unofficial builds. The last one is our Deep Computing's 100 open source project for RISC-V support. We provide RISC-V hardware for your project. So for those who are interested in this project, can go to our web page or can just come to talk with me. And for those who would like to know more information about RISC-V and deep computing, can follow us on Twitter and LinkedIn. That's all. Thank you.
Okay, thank you for sharing. We still have a couple more minutes. If there's any question, yeah, anyone can chat with Ms. Zoe. Otherwise, you can catch her. Yeah, so can we have the next speaker to get ready from Japan? Yeah, thank you. You'll be using the... Oh, using yours, okay. So, this is yeah, Masafumi.
Yeah.
Yes, Masafumi Okta from Japan, Raspberry Pi user group.
Yes.
Right, and this is the topic.
Yeah, this is the topic of the history and the building the co-working in the Raspberry Pi 500 mechanical keyboard project.
Okay, so we still have about 4 minutes. Anyone would like to just informally chat? Yeah, because the session starts at 2:05.
Special study, so I will introduce myself.
Okay. Okay.
By myself.
Wait, need to connect.
Okay. Thank you very much.
Thank you. Do you need the kicker?
Okay.
If you need the kicker, you can.
Okay. So person in my works. Okay. Okay.
Okay.
Okay. Let 3 minutes before.
Yeah, 3 minutes.
It's okay. So before I introduce by myself. So I'll say yes.
Okay.
Hello, everyone. This is small. I forgot to tell. I was using that. Sorry for that. It's okay. 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 Sorry, and I forgot that using that. Afterwards, and if you need some stickers, please pick out the way. So okay, and now I get started. Okay. Is this okay? I get started. Okay. 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 So thank you very much. So I introduce the community activities. Our community activities is about something field testing in detail, and with Raspberry Pi, and about Raspberry Pi mechanical keyboard project. Sorry, that's snip. Sorry. Sorry, snip. Sorry. Sorry for that. Sorry for that. This is snip. And this is snip. So and last year I attended a TV program with Japanese idol and to introduce and beginners with IoT and using Raspberry Pi to beginners and because of the TV program project I doing this the Nogizaka 46 is a Japanese idol. So but I sometimes ask many more countries. Last year I went to Korea to host for summit. So I attended and they know Nogizaka 46. They know well. But in Thai, so I check and so and chat GTP. Wow. And many of them don't know. Sorry about that. But please check such things. So it is the ceremony is collaboration work is and Thailand government is Novias 46. And more details for I have interviews for the Raspberry magazine about how to instruct Raspberry Pi with Japanese idol. Very difficult to teach them because I very much understand two things: idle distance and preventable injury. And idol is something like a merchant. So I very much care about that. You watch the 5 minutes TV program, but recording is 1.5 to recording. It's very hard time for me. So this is the topic is sorry as I told you, this is writing such a writing for I would love to much more things about that and the Raspberry update in the latest and Debian and many more features, especially for business. But sorry, in this moment, I would like to talk about hobby product and the Raspberry Pi 500 and mechanical keyboard. If it's for any making for the B2C, the users and education, because it is very fun to the mechanical keyboard and using the LED inside. And you see a demonstration in the Japanese and the project booth. So you see, and you can have a fun to the controlling the LED inside in the keyboard. So I started keyboard this project a couple of years ago with a Raspberry Pi, and the developers and Simon Martin. Responsible for engineering and Raspberry Pi 500 plus Raspberry Pi 500. He emailed me to please help me to make the Japanese localized keyboard and the mechanical keyboard. And he asked me to what kind keyboard and many people like. So we recommended the Logitech and personally, well, many people don't know the product and the Happy Hacking keyboard in the PFU. I introduced in many more keyboards and so they asked you and purchased and touch it. And second, and they asked me to the keyboard layout. And personally, if you get used to many more people get used to the English keyboard, but some of them ask to localize keyboard, and especially a layout, so they get nervous to also making a keyboard things, and especially a keyboard PC is he nervous to this that call in a keyboard go. So we carefully checked with the Raspberry Pi engineers about the keyboard pitching and layout. Carefully, we discussed many times how and what is a good keyboard layout for Japanese users. And we over testing and Japanese language testing. So the issues occurred and using that and so default and installer is on the pre-install is on the Raspberry 500 Plus and the layout for English keyboard. So so even once the keyboard is English, but so layout is different. That cause we can type on the special account and the character for the account name for that's useful. So I actually requested apply to the another language keyboard as a default, so they should release another type and pre-install version to the whole another language keyboard, and that may feel a shipping delay if caused by me. Sorry. And so I would like to throw one more tip. I would like to demonstrate at this moment, but sorry, I can't. It is for 15 minutes talk. And if you would like to see, please request me that I will demonstrate in at my Japanese booth. And some people, especially the YouTube influencers, and installing 500 plus to another OS, they tear down to and pick up SSD to and attach the another USB type something like SSD attachment to install in the Raspberry Pi Imager. That is not useful because the tear down is so very much carefully to especially such a mechanical keyboard. That is not useful. So I recommend Simon Martin on the engineers recommend using the RPI boot command. RPI boot command is connecting the Raspberry Pi with the USB cable to the Raspberry Pi as a storage devices. Once execute the RPI boot command, you treat as a Raspberry Pi 500 internal SSD as recognized one of the storage for install another OS to Raspberry Pi. So you don't have to do tear down to Raspberry Pi to install another OS. Please don't do that. And how do you do that? If I demonstrated the latest at my booth pressing a power button to connect it and execute RPI boot command on PC to install that. Very simple way, not to tear down and easy to install. And the issue also is issues about 500 plus, and it is LED things, and some influences and testing, but so we don't know any information about that, and it is. If you interested in the key and the LED things 500, please check the GitHub and on Raspberry Pi and their sample code and you would love to using and for that. Okay. Yes, that's a fine presentation. Sorry. By the way, why I recommended the Raspberry Pi 500 plus for the education or programming is I discussed with Simon Martin and before making a Raspberry Pi 500, and it is not. It doesn't have physical cooling, physical cooler system. It is only heat sink system that more cooler than the ordinary Raspberry Pi 5 product. It is very useful for programming for keeps using for the only programming with not using for the physical computing. That's you should try to benchmark and comparing the Raspberry Pi 500, 500 plus. The result is faster than Raspberry Pi 5. So if you use the programming and servers, I recommend using for that. Okay, that's final presentation. Thank you very much. Sorry, and this is right on Nico, sorry. And thank you very much.
Okay, thank you, Mr. Masafumi. Yes. Any questions for Mr. Raspberry Pi? Yeah. If not, could we have is Mr. Achuman here, the next speaker? No? Okay. Yeah, so the next talk is supposed to start at 3:20. Sorry, 2:20, yeah. Bangkok time. No. This is supposed to be the next talk at 2:20, but the speaker cannot be found. So you can enjoy the slides. I can scroll through them. Yeah. Our speakers are here. So they are introducing the tech project, building calm tech hardware, implementing tangible NFC configuration with free RTOS. They are Mr. Masaya Narita and Mr. Honda Takayuki. Right, so this is a 20-minute talk from 2:40 until 3 p.m. You can do full screen if you. Okay, so we'll pass the time over to them.
So can I start? Okay. Okay, so I start the presentation. Hi everyone. It's a pleasure to meet you all. My name is Masaya Narita, and I led the TAC project, and a project dedicated to about the hardware design. And so today, joining me is my teammate, is Honda-san, and who will be assisting with live demonstration later. So first of all, I would like to express my gratitude to the FOSSASIA community for giving us this, the precious opportunity to share and discuss our ideas. So today I'll be talking about the concept born from our development of a digital photo frame and a device designed to be intuitive and long-lasting use. So specifically, I will discuss the idea of using the physical NFC cards to configure digital home appliances. So the next slide. Not this one. No. This one, yes. So to give you some context, so TAC project is an initiative where we explore what intuitive technology with minimalist functionality could truly be. So while I'd love to dive into the other project we are working on alongside this photo frame, but our time is limited today. So if you're interested in this kind of hardware, please come find us afterward. I'd love to chat. So the foundation of our NFC configuration ideas is the digital photo frame, this one. So this digital photo frame has a few unique characteristics. So the first is it's about longevity. So to ensure it remains functional long time after that proprietary updating service might end. So we adopt actually the free RTOS instead of Android, because nowadays the consumer digital photo frame is based on very old version of Android. And the next characteristics is the intuitive design. So we stripped away the UI to create a minimalist aesthetics that lets the user focus entirely on the photos. So this design works well if you are just displaying photos from the SD card in sequence. However, once you add features like network synchronization or like a scheduled power on and off or auto start functionality, you inevitably need buttons for configurations. So the irony is that these buttons are rarely used after the initial setup. So this frustration led us to new ideas. Yes, to using physical NFC cards as a configuration cards. So the approach is very simple. So the perform detailed settings via the smooth high performance GUI on your smartphone, and write those settings onto an NFC card, and insert the card on the photo frame to apply configuration. So by doing this, we can access a wide range of features without cluttering the device with unnecessary physical buttons or complex on-screen menus. So let's look at how this works in practice. I will show you the screen. Yes. So go ahead. So now actually you can type the settings with the smartphone. Yeah, just type the password. Yes, and maybe set the category to play. Yeah, and also you can do authentication here on your smartphone. And finally, generate the configuration text and write to an NFC card. Yeah. Simple. And insert this configuration to the photo frame. So, and the beyond just setting to up a Wi-Fi or power schedule, so these tangible cards could be used to switch between like a specific albums. So, and I think that physically swapping a card provides a much more satisfying or intuitive user experience than navigating just a digital drop-down list. Yeah. And finally, I'd like to touch on some technical side. So in our current step, the configuration data is written to the physical card, and the photo frame uses that information to access remote storage. So since this involves storing the credentials on the card, so robust encryption is essential. So, and additionally, we are exploring whether the frame itself should handle OAuth authentication using refresh token to access photos. And this would eliminate the need for an intermediary server and further reduce dependency on specific service providers. But however, we need to balance the complexity of implementing OAuth on embedded systems against the benefits. So, yeah, we have a little bit more time, so let's see. Let me show you the introduction video. So at this stage, it's completed a proof of concept model, so there's no encryption. but we have to yeah, make it. Yeah. Yes. So thank you. So I'm eager to exchange thoughts on these technical aspects or any other parts of this project that might you interested in. And today we bring this actual device, so I'm happy to chat with you. So thank you very much for your time today.
Okay, that's a very short presentation. We still have about 10 more minutes. Yeah, so if anyone would like to have some questions or some interaction with the speakers, yeah, please feel free. Yeah, they brought the hardware along. Yeah, you can gather around to have a look if you are interested. Any questions? No? Okay. Thank you so much. Yeah, thank you. Okay, Mr. Ma, you are the next speaker. Yeah. Until 4 o'clock. Okay. Hi, welcome back to the hardware track. So before the break at 3:30, we'll have some hardware projects by some FOSSASIA speakers under the Google Summer of Code program. So first up, we have this LD badge and Magic E paper by Dr. Padma. Yes.
Yeah.
Okay.
I think it's working.
Okay, cool.
Okay. Okay, hello everyone. My name is Padmal, and I'm working with FOSSASIA and GSOC for nearly 10 years. And today in my talk, I'm going to talk about two of the very recent projects that we have, mostly hardware related, and what we have in GSOC for this two projects, LED badge and Magic E paper. And for those who doesn't know what GSOC is, it's a global program that is supported by Google. This one is not moving. Or maybe. No? No, this one is stuck, kind of. This screen is kind of stuck, I think.
This one is stuck, but this is moving.
Ah, okay. Unplug it till it works. It's still there.
Oh. Can you try on the side why the screen is stuck?
Now it's gone. Let's see. I think it's still the old screen because its time is still 52.
Okay, that's strange.
Maybe it's mirroring something.
Can someone?
Yeah, it's because the time is still 2:52.
Can we try?
Yeah. That's the right cube, right?
Do we need to restart the projector?
It was working and now.
Can we get some? Can we get some hardware help? Yeah.
In the meantime, I will pass on the hardware that we have. This is the e-paper, and this is the new version of Badge Magic. I will get to it soon. You can pass it on and have a look. This is kind of frozen. students and experts in the field with different open source projects that we list in the GSOC page. And what this does is, this allows university students or those who are new to open source to get experience from the experts and until the end of March. And the organizations will review these proposals, and by the end of April, you will get to know that if you can continue with GSOC, and you can start working until November 11th. And if you scan this QR code, you can go to the whole timeline and the GSOC official web page. And FOSSASIA has been with GSOC for many years, and this year there are 2 new projects, mostly hardware related, that I passed around the hardware, are going to be in GSOC, and one is Badge Magic. Typically in a hardware project in GSOC, we have 3 main repos. One is for the firmware, one is for the hardware, and one is for the user applications. Could be Android, or recently we ported most of our apps to Flutter, so it gives us cross-platform applications. So Badge Magic is what you probably have in your swag bag. It's a small badge like this. It allows you to display any sort of text or clip arts that do various animations, and it's fully open source, so the hardware and everything. And in GSOC, we are listing down 3 main ideas that are related to Badge Magic. We already have the Android application. It's quite in a very stable state, but of course it needs to be polished out and updated with all the previous libraries that we are using. So the first idea is to enhance the Flutter app that we have for Badge Magic, and we estimate it to take around 175 hours. That means like a medium scale project. And in this project, you will use your knowledge about mobile app development, mostly using Flutter and Dart, to improve the functionalities by testing the whole app and see if there is something broken, that you would fix it. And also, we are going further. We are going to have many options that you can share whatever the animation that you create with another user by sharing this through the app, and also have a reliable release process so that you can deploy this in App Store or Google Play, so that you can have users download this one. And the second idea that we have is, currently this hardware, if you have seen, if you want to update the firmware, it's a bit hectic. You need to remove the battery and have some key pressing sequence that allows you to upload the firmware. This is a bit troublesome, and it's very risky. It could burn the badge. So in the meantime, we were exploring different ways, and it turns out there are some firmware, only based on firmware, that we can upload the bootloader without having to tinker with the hardware. So in this work, who is well versed in C++ could work with in this program. It would take about, we estimate about 90 hours. It's about a small scale project that can step over this battery removal process and to implement a firmware only method to upload the bootloader and the firmware. And the third idea is that we have a new badge developed, and you might have noticed that it has more buttons and some speakers, and also you might not notice that there is an external memory in the new badge. But these features are not supported in the existing firmware or the Android apps. So this task is to improve the firmware so that all these new features are implemented, so that users can have the microphone. For example, it could show the voice pattern on the badge itself in real time, or there are 2 buttons that we intend to have some games on the badge that you can play. All these features, we estimate it would take about a medium-sized project, and also so it will make the new hardware more compatible with the firmware and the Android app. And the next project that we have is Magic ePaper. It's rather new, and something that looks like this. And on my right side, we have this ePaper, so-called thing. And this hardware does not have any battery. So what happens is, if your phone has NFC connection, that you can power up the ePaper using this magnetic coil on the behind, and write some static image on the display, and then it will stay on forever. I mean, yeah. And in regards to this project, we have two main ideas. The first one is to improve the Android app. We already have the Flutter version that works well with Android, but we need to test and improve the iOS version, and also test with how the iOS NFC works with the ePaper, and if we find some problems, we need to fix that. So it's kind of a large-scale project that we estimated would take about the whole summer, and all these other features that could allow us to draw different text or draw different patterns, that altogether that builds a full comprehensive app that works with the Magic ePaper. And the second idea that we have is, right now the Magic ePaper supports only one type of ePaper drivers. We need to make the firmware modular so that it can support any ePapers that are available in the market, because they are pin out and everything is quite similar. It's only the firmware that should be changed. And so in this project, we are going to revamp the firmware that we have already, so that we can support multiple different ePaper displays and drivers, and also support all these communication protocols, and test the whole firmware stack, so that we have a comprehensive platform for Magic ePaper. And these are not an extensive list. There are so many GSOC ideas that FOSSASIA has during this summer, and if you scan this QR code, you can go to the whole list. And then that's it. And if you have any questions, I'm happy to take them.
Okay, any questions for Dr. Padma? Any university students here? Would you like to work on GSOC? You get paid by Google? Okay.
You don't. I think until 2 years ago, you didn't need to be a student any longer.
No, yeah. They changed that. And
is it back to student, or is it?
No. It's still. I mean, they say it's open to university students and those who are industry, but they emphasize on first-time contributors if they're from industry.
You need to be new to open source in general. But
Thanks for clarifying. Okay, please look for Dr. Padma. We have another GSOC project mentor, Mr. Mark Noss, who will be sharing about another project, which is the PS Lab or Pocket Science Lab. Okay. Okay, let's welcome Mr. Mark.
Yeah, thank you. Hello and welcome to my talk. I will talk about the Pocket Science Lab and how to get involved and how to contribute during the Google Summer of Code. My name is Mark, as already mentioned. I'm a software engineer and free software contributor for a little bit more than 20 years. I started with a search engine project called Yassi, and there's also Michael, who dragged me into this whole thing. I contribute to the Pocket Science Lab since 2019, when I asked Mario of FOSSASIA, what is this pocket science thing? And he gave me a pocket science lab and said, yeah, have a look and maybe you have something to contribute. That would be great. And yeah, now I'm here. I've been a mentor for the last 2 Google Summer of Codes and will be a mentor this year. And yeah, I'm happy to be a mentor because I think it's pretty rewarding to see how the students develop, how they become experts in what they are doing. And most of the times they know their domain of the contribution better than the mentors in the end. So that's pretty nice, I think. Yeah, but what is the Pocket Science Lab? The Pocket Science Lab is a small hardware. It really, sometimes you have handbooks and they don't really fit anywhere. The Pocket Science Lab is really small enough to put it in a pocket. It's no lie, and is affordable. So students can buy it, or you can, if you're, you don't need to be afraid to break it because it doesn't cost a fortune. You can connect this board to your phone or PC, and that makes it a measuring device. We have also an app and a library, so without software it would be worthless, but we have this app, and you can control the board with the app. And you can connect with USB or Wi-Fi, and Wi-Fi has this little asterisk there and says additional hardware required. You need a small ESP01. It only costs a few dollars and forwards all the information to the Wi-Fi. Because I mean one big thing around here is AI, and I uploaded my slides to Copilot, I think, and it said, nice slides, but what is it actually good for, this thing? And it gave me this sentence, which I think sums it up pretty well. You have this open source hardware ecosystem that empowers students, makers, and researchers to perform scientific measurements everywhere. And that's what it is. You can take it with you and use all the different tools. For example, you can use it as a multimeter. This is a screenshot of the mobile app. And you can choose the different inputs and measure different things, like the voltage up here. I think it's up to 16 volts. Then you can measure frequency here, and capacitance over here, and of course resistance too. So if you have a bag of resistors and you don't know the color codes, you can use this to measure them. Then for me, this is the highlight of the device is the oscilloscope. It has 4 channels, and with those channels it measures the voltage over time, the way it changes. You can see that in this curve. It measures up to 2 million samples per second. That should be enough for signals of up to 1 megahertz. But I think it's best in the kilohertz domain. And we can not only measure the voltage, but you can also use the device as a logic analyzer and measure logical high and low, like this. Maybe if you have a bus where devices communicate, you can look at that, and it has 4 channels and up to 4 megahertz. I always say up to because the channels, they share the bandwidth, so the more channels you use, the lower the bandwidth gets. In addition to the tools I mentioned, there are also additional things like the wave generator. It creates sine waves or triangle waves, but actually it's you can use arbitrary waveforms, but we have only implemented sine and triangle so far. yeah, you can use that as a test signal. For example, for development, I use the sign signals all the time to look at the oscilloscope and see if everything works all right. But you can also make music with that. I have done that. Unfortunately, I didn't record that, and so we can't listen to it, but it works. And we also have those for pulse wave outputs. You can, for example, use them to drive servo motors. And I have a small robot arm at home, and it can work with that. And also, programmable power sources, and we can also add sensors which communicate via I2C. So it's a pretty universal device. But without software, it would only be a nice board without any function. On the board, of course, we have firmware. The firmware is open, developed by a contributor. Then we have an app. It's Flutter-based. We used to have an Android app, but we changed that to Flutter to also support desktop applications. And we have a Python library which you can use as a base to build your own applications. The question is, how can I contribute? The first thing is, if you have a board, of course, use it and tell us, because only if users tell us what they do with the board, we know how we can make that better. Then there's a possibility to translate the app. We use Weblate, or you can add your translation directly to the Git. Then, of course, always all open source projects want you to report bugs and send new feature requests if they're reasonable. And since we're a small team, we're always happy if we get patches. So if you find something in the bug tracker and you think, I can fix that, do that. Would be great. As I said, we're a small team. We rely on Google Summer of Code students for bigger features, and we already had very successful contributions in the past. For example, the whole conversion from the Android app to Flutter was done by GSOC students. Or one GSOC student last year, he created a prototype of a new board. So that's pretty cool. Contributions are open, as Padmal already pointed out. So I thought I'd bring two ideas which we had. One is, I already said, you can use Wi-Fi to connect to the board. And at the moment, we have two different firmware versions. And you have to decide when you compile it, which version do you want to use, USB or Wi-Fi. And it would be great to be able to switch that during runtime so that you can just reconfigure the device without flashing new firmware. That would be one idea. That's more hardware related. The other one is a little bit more software related. As I said, we have a cross-platform app. And we have already tested the mobile versions. They work pretty good. But we haven't tested the Linux, Windows, and macOS versions yet. Well, I've used them, but I've not really tested them. So we need somebody who tests and fixes bugs. There will be bugs, I'm pretty sure. And we also would like to release the app to the software stores that are available on the systems. And that would be the other idea. We have more ideas. The QR code takes you to the list of FOSSASIA ideas for GSOC. I think it's probably the same website that Padmal shared. And you can go to the website. I mean, it says PSLab.io on every slide for a reason, because that's the web address. You can visit us here, or if you see me walking around or just sitting somewhere and want to talk about PSLab, then do that. And if you want to buy a PSLab, you can also ask me. And that's my talk. Any questions?
Any questions from the audience? Can I ask about about how many number of hours for the ideas? Because Dr. Padma shared that it's about
Yeah,
170.
when I saw his slides, I said I missed that. I think I think they're both medium sized, but I'm not really sure. It's in the if you visit this address with a whole list of ideas, they all have the hours that are estimated. Yeah.
Great. Yeah. Thank you.
Yeah. Thank you very much.
Yeah. Thanks very much. Okay. So please feel free to interact with your speakers. Now is actually break time. We have a 20-minute break until 3:50. Then we will start the Web3 track also in this room. Otherwise, there is Dunkin' milk tea outside. Yeah. I'll see you around. The first speaker is here. May I know whether the second speaker, Mr. Mario Havel, you are here? Okay, if not, Mr. Sapri. Okay, doesn't matter. Okay, so yeah, to start off with the Web3 track, we have Mr. Diago talking about Monero. Right, so we'll get him start the talk.
Alrighty, perfect. Okay, let's give this a go. Okay, I got a lot to cover and not a lot of time to do it. I usually have this as like a 30-minute talk, but this is only a 15-minute talk, so we're going to have to go quick. I'm going to have to pretend I know everything and you guys know nothing, but that's going to be an easy thing to pretend because it's probably true. So, my name is Diego Salazar. I have done work on, around, and with Monero for a long time, approaching on 10 years here. We're going to talk about Monero, what it is. Who here has heard of Monero before? Yeah, I'm saying there's one. Who here owns some Monero? No, nobody's raising their hand. Good. Don't tell anyone you own Monero. Okay, Monero. What is it? To understand what Monero is, we actually have to go back a little bit and see what Bitcoin is. So we're going to be talking about kind of blockchain in general, move to Bitcoin, and from there move to Monero, and everything will make sense. So Bitcoin as a whole was kind of started with 3 pillars in mind. There's kind of a historical ethos to it. There's the economics portion, and there's a technology portion, sorry. There is more. There's like cryptography and there's mathematics and stuff that hold all this stuff together. But we're kind of focus on these 3 pillars and what they bring to the table. I run and own a company called CypherStack, and we do design, development, infrastructure, and research. I hire 4 cryptographers. So I do know, for those of you who are like, oh no, there's cryptography in there too. I know. We actually do the math stuff to actually make that work. So a lot of fun stuff here. The ethos, the heart behind Bitcoin, again, we're going to be talking about Bitcoin. We're getting to Monero, don't worry about it. The heart behind Bitcoin is actually a big one. It's this idea that comes, even with all of FOSSASIA and what they were talking about on the main stage, it's people collaborating, it's people coming together. Bitcoin, as you guys know, is open source. That's why people can fork it, make things like Litecoin and all this other stuff, right? And it needs to be open source for several reasons, game theory reasons, cryptography reasons, but it also needs to be open source for ethos reasons, because the idea behind Bitcoin was to create a money that is kind of from the ground up, to kind of take away the monopoly that the governments of the world have on money issuance, the ability to print money at their own leisure. And that can only come if it's like a money for the people. It needs to be a money by the people. It needs to be a very grassroots thing from the ground up. And so that's kind of where the cypherpunks come in. Cypher with a PH, not cyberpunk, cypherpunk. And the difference is that cypherpunks are people, I'm just going to define this very quickly. Cypherpunks are a group of people who believe that we can change the world through technology and cryptography. We believe that we can make meaningful social change with technology and cryptography. We're going to go ahead and look at what that actually looks like. The human attack vector is the one that we are trying to solve. We are under the assumption that humans are corruptible. And if you give humans power, they will oftentimes do things for their own benefit or for their friends' benefit or any of those kinds of things. This is called the human attack vector. Whenever we introduce humans, there is the potential, and more than the potential, the likelihood of corruption. So what we are trying to do is we are trying to erase that ability for humans to sink their little greedy little claws into all of the things of this world that we have, like money. And the biggest one, and the reason actually why Bitcoin was made to begin with, is way back in America. I'm from America, so I can speak about us and kick us in the shins. Way back in America, in about 10 something. When was Bitcoin made? Somebody tell me. Yeah. There was a bailout by the government because some bankers were playing fast and loose with money. They were basically gambling other people's money, and they lost a whole bunch of it. And they're like, well, if you don't give us some money, then we're going to go into recession. So instead of letting these people who played fast and loose with other people's money suffer consequences, not a single person went to jail, the government said, okay, we're going to print a bunch of money and bail these people out, which we're going to get to what printing money does. It's inflation. But basically, they put an invisible tax on everybody, so that way a select few people don't have to lose their money. We socialized their mistakes. And this is because people are corrupt. The people that were playing fast and loose with other people's money are corrupt, and the people that said we're going to bail you out are corrupt. So Bitcoin comes along, oh yeah, we'll get there. Bitcoin comes along and says, no, we are making it so that way there is 21 million coins and that's all there will ever be. This is a social contract. This is enforced with mathematics and cryptography. It doesn't matter who's in power of the world. It doesn't matter who's merging code in Bitcoin. This cannot be changed. This cannot be changed. We are removing the human attack vector from money issuance. This is kind of the cypherpunk way. We identify a problem where human corruption can do damage to real people, and we remove that and enforce it with cryptography. We did talk about free open source software. Sorry, I'm a little bit scrambled here because we got to get through this, guys. We got to get through this. Okay, we're going to go to the next pillar, economics. Bitcoin is money. That's what it is. It's meant to be money. It's meant to replace money. It's meant to be alternative money. It's meant to be money. And money is used for all the different things, right? It's used to save. It's used to spend. It's used as a unit of account. I don't know if medium of exchange. I don't know if you've heard all of these terms before. If you haven't, feel free to give them a Google. A lot of fun. This is a fun rabbit hole to go down. How does money work? In learning what Bitcoin is and why it's important, you actually learn about money in general and what it does, who makes it, and how it affects our everyday lives. Obviously, the goal of Bitcoin is to be an alternative money, and the same is true for pretty much every coin that's come out. I retract that statement. Most of the coins that come out are there to enrich the founders, but we're gonna move on from that. Value. What gives something value? I will wait for 2 seconds. Who has an idea? What gives something value? What? Belief, yeah, okay. Okay, yes, okay, there's two primary things. One feeds into the other. One, there has to be agreement that something has value. Who here has heard of Club Penguin, which was an old game that you played online way back when? I never played, but this is the example I like to use. If I have Club Penguin bucks, I don't know if they even had those, but let's pretend that they did, and you do not play Club Penguin. I say, look, you have eggs, I want eggs, I have Club Penguin bucks. I should update to Robux, right? Because everyone plays Roblox these days. So I have Robux, you have eggs, let's trade. Well, you don't play Roblox. So you're like, this isn't worth anything to me. There's no agreement between us that this thing has value, so it doesn't. But if you do play Roblox and you're very religious about it and those Robux mean a lot to you, then you will say, yes, I will give you my eggs, and you give me your Robux. Man, that's hard to say. And so there is agreement between us, so there is value. But yes, there is a second thing, and that second thing is scarcity. If we go to the beach and I grab some sand, I say, let me get your eggs with sand, and you reach right down and pick up your own sand and say, I am just as rich as you in sand. Sand is very plentiful. It is everywhere, so nobody needs it. There is also artificial scarcity, where some people will make only 10 guitars. They can make more. It is physically possible, but they will only make 10 or have only a certain 10 signed by a certain musician, and it makes artificial scarcity, and so people will go ahead and purchase into that. But this does actually just feed into agreement, because we can all agree that because sand is not scarce, there's no value. Or we agree that because there's only 10 of these guitars, it will fetch a higher price. If Justin Bieber blew his nose into a tissue, it would sell for higher, depending on who agrees that that's actually valuable. Okay, yes, we're going to go to the technology portion now. What is blockchain? What does it do? Why is it important? What is the purpose? How much time do I have? Oh my gosh. Okay, okay. We gotta go fast. Who knows what a database here is? I'm pretty sure most of you guys do. It's a place where we store data and we can retrieve it later. There is a problem though, and it goes all the way back to the human attack vector. We can have people, for every database there needs to be a system administrator. Right? There needs to be somebody who can access that data. And that person, we are trusting that they are good and that they are competent. Because if they are good but incompetent, then they put up bad firewalls, they put up bad security measures, and next thing you know, somebody else is getting in there and changing the data. If they themselves are not good, but they are competent, then they can mess with the data and hide their tracks really well, right? So you can imagine, going onto Amazon and somebody, the system administrator lowering the price of a TV, purchasing the TV, and then raising the price back up and hiding it, and now they basically just got a free TV. So there is a human attack vector component to databases, and this is scary when it comes to money. We try to solve this currently with things like laws. We make it illegal to go into those databases and adjust people's balances, but law can only go so far, and as we have seen, when I spoke about why Bitcoin was created and the people printed an infinite amount of money, sometimes the consequences for not doing the things you're supposed to do are pretty lackluster depending on who's in charge. So we try to blockchain, for those of you guys who don't know, is an append-only database. Basically, we can put new information on there. We cannot take information off there. Big asterisk, mining, we're not going to go into that. We don't have time. But for our purposes, it is an append-only database, but everyone can look at it. Everyone gets a copy of it. When you download the blockchain, you have your own copy of it, and you can see how much is in your account, how much is in other people's accounts. So yes, I can go into my own database and say, haha, Diego now has 0 to 100 Bitcoin, and I try to spend it, and you say, well, according to my version of this database, I don't have you as having 100 Bitcoin, you have 0 Bitcoin. And I checked with my friend over here, he also says you have 0 Bitcoin. And we checked with this guy and this guy and this guy and this guy. We all agree that you have 0 Bitcoin. So yeah, you changed yours, but nobody's gonna accept your money because it's not real. So everyone gets a copy of that, but it comes with a trade-off. You can see everybody's money. You can see everybody's money. And I don't know about you guys, but I'm not about to come here and open up my banking application and say, see, you see how much money I have and you see what I spent it on? I'm not gonna do that, it's my money, it's private, right? So Bitcoin is radically transparent. That comes with pros, and in my opinion, that comes with a lot of cons. Bitcoin is very radically transparent. That's why we have, hello? No other slide. That's why we have Monero, woo! Monero is basically just Bitcoin, but secured with a whole bunch of privacy technologies. As of right now, that is ring CT, ring signatures. We don't have time to go into how those work because goodness, I have 4 minutes. But as you can see, we've spanned a whole little super quick thing going from Bitcoin to Monero. I'm going to spend a little bit of time on privacy coins in general. Monero is just kind of the biggest among them at the moment, the king of the privacy coins, as they like to say. We utilize, there's other privacy coins in the space, by the way, Zcash, Firo. Ruben over here is a representative of Firo. So there's a lot of privacy coins, and they utilize different privacy technologies because privacy is its own field, doing its own thing. And this is the crazy thing about blockchain kind of in general, is it is game theory and cryptography and economics and all this stuff like squished together. It's not just one thing. And you have a lot of Dunning-Kruger effect here, where you have people who are good at one thing, and they think, well, because I understand this, because I understand game theory, I can understand the cryptography, and I can understand the privacy behind it. You got to sit them down like, no. See, you don't just need to understand each of these disciplines. You also need to understand how they work together, because making a append-only, viewable by everybody database private is really hard. You can use heuristics and statistics to reduce anonymity sets. You go, and for similar topics, you can go look at Tor. How do people get de-anonymized on Tor? And you get kind of similar stuff. Full-blown encryption, oftentimes putting privacy technologies makes the individual data, the individual blocks so much bigger, the individual transactions so much bigger. How are we going to scale this thing, man? How are we going to scale this? How are we going to get it out to all of the world if everyone starts using it? All of a sudden, we're really hurting, our blocks get super huge, and nobody can sync the blockchain anymore. There's trade-offs. I'm not saying this is the way to go. These people have it right. But I do know that, yes, I do want money that is not controlled by people that have this, corruptibility. But I also do want it to be private. And so I do think it is worth the time and the effort to go into these with not the assumptions that, Bitcoin's the biggest, so it's going to be the thing. Ethereum's the biggest, so it's going to be the thing. Go to these coins, go to these founders and say, when do we get privacy? When do I get to not show everybody what's in my accounts? because I want to be private, and that is a reasonable thing to do, and privacy is not for criminals. I want to be private because privacy serves me. I want to be private because if somebody is using tainted Bitcoin from the darknet and they buy just a t-shirt from my t-shirt business, now all of a sudden I have tainted Bitcoin and people are knocking on my door saying, what are you doing with that Bitcoin? I'm like, I just sold a shirt, dude. Yeah, but we traced this back and it's drug Bitcoin. I'm a squeaky clean guy. But all of a sudden, I'm part of an investigation for something I never had to do with. With privacy, if everyone's private, you don't have to go that route. You don't have to live that life. It's not you who you have to be careful of when you're driving on the road. You could be the safest driver, but if there's somebody who's not a safe driver and they hit you, you're still hurting. That's why Monero, guys. That's why privacy coins in general, if the other Web3 people come up here and say, I've got this cool idea, you say, where's the privacy? Where is it? We need it. We need it for freedom. We need it for whatever. Okay, that's basically my time. Man, I speedrun this thing. I did. Thank you so much, guys, for bearing with me. I hope it was legible. I hope it was recorded, so if I went too fast, you can go back and watch it again. I'll pass this off. Thank you.
Thank you.
I'm around for questions outside afterwards.
Yep. May I ask if Mr. Mario Haver is here? Okay, cool. Okay, so please feel free to engage with Mr. Diago. You are using our own laptop?
Yeah, can I just plug in? Yeah, sure.
I'm outside for questions.
Great job, Diego.
Thank you.
Okay, so our next talk is by Mr. Mario Haver from Ethereum Foundation, Border Hackerspace. Yeah, so let's pass the time to him. It's a 15-minute talk. Yeah, thank you.
Awesome. Thank you so much. I have a mic. There is one. Okay, welcome everyone. Thank you so much. Diego actually had a great talk before me, already diving into the blockchain paradigm. And in this talk, I don't really want to talk about why is blockchain or Ethereum cool and important. More about like how we even keep it running and what does it. How does the maintenance, the development, and this open collaborative coordination work under the hood? So I'm part of Ethereum Foundation, a non-profit organization that helps to facilitate this sort of coordination and supports these efforts to keep Ethereum running. But it's only part of it. So just to maybe quickly recap what was also mentioned here, this whole ecosystem of cryptocurrencies, Ethereum, comes from the cypherpunk movement, from the free software movement, from the dream of digital cash, of having some decentralized, no central authority system. Matthias, hey. Nice. So when we have open and permissionless system, it cannot have a central authority, right? I'm talking about being from Ethereum Foundation. So how does it work? That's the challenge. How we can create technology that's its purpose is to bring freedom and empower individuals. But with this, we need to stay censorship resistant. We need to stay free by ourselves in the development process itself. So these are our challenges. It's not just that we don't have a central entity. We result in many teams that independently collaborate on making something happen together. It's actually like maybe 24 teams that need to agree on something. So it's not easy to agree always. I will get there. But it's not just the coordination and the human problem and the free software limitations that we know from a bunch of these open source projects, but it's all critical what we work on. So Ethereum is running non-stop for 11 years almost now. The chain never stopped. The chain never halted. It's always creating new blocks, always millions of people using it on daily, weekly basis. The transactions keep processing, and we cannot shut it down because there will be a bunch of problems. So all of these upgrades and everything needs to happen with critical security in mind. We are talking about billions, hundreds of billions of dollars that the network is running, and we as sort of like, you know, gardeners, like just people taking care of it, we cannot interrupt. We need to be careful what sort of changes we are doing. So it's technically also very security critical, but also from the research perspective or from technological perspective, also what was mentioned here, it's very hard to develop such a system because of all the technological limitations in the blockchain itself. So the decentralization being the main thing. If we want to scale it, if we want to allow for more transaction, the idea of the blockchain is that everybody can process everything. So if my laptop is part of the network and suddenly there is more transactions that my CPU or hard drive can handle, well, I'm out of the network. I cannot verify everything anymore. If we want everyone to verify everything, we need to include basically the smallest laptops or smallest computer that can run the network. So how do we overcome this? Like, it's a very interesting research to bring more scalability, also privacy, also better user experience, because this whole private key transaction system is kind of convoluted for people coming from like a regular world. So also the UX challenges. So a lot of challenges we are dealing with. So how does the Ethereum development works? What everything goes into it? Because it's pretty big under the hood. And so what I want to highlight here specifically is that, for example, the Ethereum Foundation is just one organization out of like dozen that works on Ethereum itself. There are people working on the research that come up with these ideas and creative computer science hacks that enable us to push the blockchain to the future, to enable more people to use it more easily. Then there are the client teams themselves that implement it. So this is something that's very interesting and unique about Ethereum, because we have like literally a dozen client teams or clients. Ethereum is implemented in two parts, in execution and consensus. Each of them has like 6 implementations. So what does it mean is that Ethereum is specified somewhere, but it's implemented in 6 different languages, right? In Java, in Rust, in Go. So like whether you are a developer, you can choose what language you want to contribute in, but also we are not dependent on a single client, on a single team or so, right? I don't know, but Bitcoin, for example, it's largely dominated by Bitcoin Core, the single implementation, because it came from Satoshi, the legendary creator, right? It's hard to argue with that. But Ethereum comes from community that agreed on some spec, and the spec was implemented in various ways. So these are different organizations, companies, for example, building business on Ethereum, and well, as part of their business, they want to have their technological expertise in mind, so they invest into building their own Rust client, for example, therefore, these are like maybe some research teams in Ethereum Foundation, but they need to work with all of these different clients that actually touch the code, and they can tell you that, okay, maybe it's theoretically interesting idea, but practically speaking, it's not really feasible to implement, right? Now, of course, the security and testing teams that are very robust, because deploying something on this whole network needs to go through very rigorous testing. There is many interesting processes. We do, of course, fuzzing and shadow forking and different test suites across clients or within individual clients. The security of the network is guaranteed by this, but the idea again is that if we have 5 different clients, each running like 20% of the network, and one of these clients has a bug that the testing didn't caught, well, only 20% of the network is down, and the network keeps running. We have the 100% uptime. We still are creating blocks. Only some people using this client have problem and need to update to the fixed version. So that's how we stay active. And all of this, of course, comes together with the community, the actual users of Ethereum, the people building the apps, people using the wallets, the actual users, people in this room who somehow want to use it. They need to agree what's happening. So if the research or developers come up with some crazy change, how to make it better, but it sacrifices, I don't know, privacy or security or censorship resistance, the community comes and says that, no, we don't accept this. We are not going to upgrade to this version, so you need to rethink that. So lots of discussion. When something is happening on Ethereum, we had bunch of great upgrades over the years, and it's always the same process coming from some research ideas through the proposal. So we have EIP, similar to Python improvement proposals, right? So like a community process where anybody, really anybody, can just propose an EIP. But then that's the easy part. The hard part is actually pushing it through this community, to advocate for it, to push it through the all core devs, as we call that, a discussion of all these core developers who need to agree that this is really worth our time to implement it, to test it, and then finally push it on the mainnet. A couple of tools that we are using you might be interested in. So everything actually starts in the repo. We have a EIP's repository where all these proposals live, and again, anybody can open a PR to basically submit their EIP, and the discussion to these EIPs is not happening in the repo, but in a discourse forum, Ethereum Magicians. So that's where people come together to actually discuss this process before it goes through to some calls or so on. And for more like primordial soup, for more like research-oriented, not specified EIPs, but more like general idea how we could improve Ethereum, we have another discourse forum, because there is never enough forums, Eat Research. So that's another place where you can just talk and learn lots of cool things. And finally, there is Forecast, and Forecast is a tool that we developed in my team, actually, to really have a clear transparency and simple overview of what is being proposed, what is happening right now, because with all of these different venues, it's kind of messy, right? That's one challenge of this process. With so many different people working on so many different things, you don't have a simple overview of what is the current state of the discussion. So that's what Forecast is trying to be. And overall, we have this process kind of is all encompassed in the all core devs. So every Thursday, people representing all these different teams, more than 15 teams. There is like around 100 people in these weekly calls across 15 different teams that come and discuss, and it's completely open. Surprisingly, we are not getting Zoom bombed anymore, but like we have a public call where anybody from the world can join and discuss with us what should Ethereum focus on, whether the implementation is very technical, of course. You need to have some technical level to be able to understand. So it's sort of technological meritocracy that anybody can really chime in if they have something to say, similarly to, I don't know, Linux or so. But Ethereum is doing it much more fast, and I think what's interesting, it's really dynamic, the way that we are able to pull this off. So I'm not sure if I have the slide here. No, it's all right. I wanted to make it shorter, but I would just mention a couple of things that we achieved. Like in 2022, the merge happened. That was the biggest upgrade at the time when Ethereum switched the consensus from proof of work to proof of stake. So as you know, the cryptocurrency is being mined by computing a bunch of hashes. We also call it proof of waste, basically just a proof of that you've done a shit ton of computation. And it's very, very simple, actually. If you think about it, it's very elegant, right? If somebody was able to do that many hashes, it means that we can trust him because there's so much computation. Well, we developed a whole completely different consensus in its own consensus engine software implementation and merged it with the existing Ethereum. So the fundamental way how the whole consensus in the network is achieved was changed to something much more complex, but also allowing us some new cool things and more scale and so on, better economic security. But what it means that like 99.9% of the electrical usage of the whole network just was wiped in that moment. It was like maybe, I think somebody calculated, this was like 0.2% of the whole world electricity went to mining Ethereum. Much more goes to Bitcoin, of course, but at least in Ethereum we erased this footprint and opened a bunch of cool venues to upgrade Ethereum. And just a couple of months ago, actually, the latest upgrade was FOSSASIA, which lets us to use KZG commitments cryptography to distribute the data in the network in a way that we can scale maybe 10 times or 5 to 10 times in a way that my computers can still verify everything but doesn't have to download all the data, only like a cryptographical proofs of those. And I can go to much details there, but these are really cool things that we are able to put on the network while maintaining it secure and fast. But it doesn't come for free. So yeah, the the cool things that I believe we achieved and anybody can get inspiration from is like, we are able to do it fast and stay neutral. What I really like with organization like this across the different teams is just the diversity. That it comes from global talent of people from different countries and backgrounds, and just the diversity of inputs really makes it really creative, and we can challenge each other, and in a really special way. I think that like comparing to more like traditional companies and corporate, it's always a competition, right? Like you have a company implementing a similar thing, so you're competing. But here you have multiple teams implementing literally the same thing, but they do not compete, they collaborate, which is great, which is beautiful. And we have all this public knowledge compounded, and I'm running out of time, so just quickly to mention some challenges, because it's not easy. So maintaining all these different clients, it's kind of pain doing all, because okay, we have 5 clients on each layer, that's 25 combinations. Actually I mentioned 6 because there's some experimental, that's 36 combinations. So it's really not easy to grow this. And actually the biggest problem that we have right now is to agree on stuff. As I said, it's really cool. We have 200 people doing their stuff across different teams, but everybody has their own pet project or feature that they would like to see on Ethereum, and to agree on this, to prioritize, that's really hard. So we have some process where we first discuss the biggest changes, the most crucial changes, and then the smaller changes. And yeah, it's a pain that I'm also happy to discuss later and maybe get some inputs from you guys. Thank you so much. If you're interested in more, check out the protocol study group on this QR code, epf.wiki, with all the information about the Ethereum protocol. You can dive into that, and it's running right now. Actually, today we have a great talk on cryptography if you're into math. And we will see you in DEF CON in November. It will be the biggest Ethereum developer conference. And if you're interested in me specifically, here are some of my links. Bordel is the hackerspace in Prague. If you're visiting Prague, come to see us. Thank you so much. Sorry for running late.
Okay, thanks very much, Mr. Mario. Does a quick shout out, or Mr. Rami is here? Good. Thank you. You have your own laptop? Okay. Thank you. Oh, you have a adapter?
No.
Is there a mic? Okay, so our last Web3 talk is by Mrs. Rami from Mishcash, the Cambridge Analytica movement. Crypto isn't ready for.
I need to mirror it.
Yeah, you need to do something.
Sweet.
Sure. Okay, please. So your talk ends at 4:40.
4:40.
Yeah.
Okay, thanks.
Thank you.
Hey there, guys. So this is about Cambridge Analytica moment for crypto. And so 2 people walk into a bar, and the first dude gets a Negroni, the second dude gets a beer, and also the entire financial audit of the first one for the last 10 years. It's not a joke. This is how blockchains work today. So how does it work? How did the second guy get the financial profile of the first? So wallet A paid for the Negroni, and wallet B paid for the beer. When wallet A paid for the Negroni, he created a permanent immutable record on the blockchain connecting him with the bar, and then when the wallet B interacted with the same bar, he trivially extracted the information of the previous transaction based on the timestamps. So you might be like, okay, this sounds a little bit serious, Shami. Now, why is this not a huge problem? So to get into that, let's check out what the early blockchain transactions were like. So you would be buying some crypto, you'd be doing some swaps, some trades, maybe minting some NFTs.
all of these transactions sort of resided in their own subspace, disconnected from your real life. All these transactions were sporadic, abstract, and did not really connect with your life in the real world. But now the companies like PayPal, Stripe, and Visa are all actively working at building these on-chain stablecoin-backed financial rails. And now these transactions can actually encode the time that you wake up based on where you get your cappuccino, where one might find you based on your spending habits, where you get your lunch and stuff like that. Did you just get a bonus? What's your financial status like? Are you under financial duress? Based on the assets that are logged for your wallet. Let's take a step back and see what Facebook was like back in 2008. So people built a network, Facebook people, and then all of us decided to share our information on the network, liking stuff, making comments, posting stuff. And no one who was building Facebook back in 2008, during 2010 and so on, knew what could happen and how it could be used as a massive tool for surveillance. Here's a little outline on what Cambridge Analytica did. We can get into a bit deeper dive. Do we want to get into a deeper dive, or? Yeah? Okay. Cool. So there was this dude who was like a researcher at Cambridge University. I think his name was like Dr. Rogan, and he did like a little app which would do like a personality quiz. And then these people gathered data from about 300,000 users. But back then, Facebook's policies were a bit like, you can get the data of the people who are using your app, but you can also get the data of the friends of these users, which allowed them to aggregate data of like 80 million profiles, basically. And they prepared a deep psychographic profiles of all these millions of users, which they later sold to Cambridge Analytica for good profits. So let's see how it maps to crypto. We are in the phase that Facebook was back in 2008 and 2010. And what someone would do today would be to basically have an indexer watching all the blockchain transactions, look for identity signals, for example, your social maps, like social connections with your wallet, which a lot of airdropping people sort of do. And then basically you're going to have these wallets connected with social profiles or other identity signals, and boom, you have a massive profile of all the spendings that this wallet is doing. This is actually live. Today, Chain Analysis, which is a huge company, it's aggregating all this data and tying readily the blockchains to actually real-world entities, and they're selling all this data to governments, tax people, and so on. They have like 1,500 plus clients which are actively paying and using their services. So yeah, and what could grow on top of this? Now, a broker who is like more interested in exploitation, since this data is already available, they could create spending categories. They could figure out financial stress indicators. They could classify your lifestyle and sell all this data, which is like very rich data, to insurers, salespeople, governments, obviously, and so on. So why could this be worse for crypto than it was for, let's say, Facebook and like, you know, other breaches? Blockchains have no access control. That data, when it's there and someone figures out how to exploit it, everybody's going to be able to do it over and over again because no one is going to be able to put a stop to it. Secondly, like Diego pointed out, all the data is fully permanent. It's append only. You cannot quite replace stuff. And that means that
the data is just there, and unlike Facebook, you cannot just, unlike what the law asks you, like GDPR and stuff, to remove that data, no one can quite remove that data, sadly. And last but not the least, bless you, no worries. Last but not the least, this data, like Facebook's data was rather abstract. It was behavioral information. So you needed a huge amount of data for it to be purposed into something useful. But here you're getting direct financial data, which is much more richer in quality and doesn't need quite that large scale to be useful. So we're going to jump into privacy pools that already exist. We have like Zcash, we have Monero, we have Tornado Cash. We have Tornado Cash's next iteration, which is like privacy pools. And we have a lot of solutions. But we are still waiting for widespread adoption. And why there's no widespread adoption? The first hard problem is the compliance wall. We have AML, we have KYC, we have travel rules, and you can't really expect a fintech that's operating in Singapore to adapt and use the same compliance rules as the one that's in UAE or maybe in Germany. So fintechs have to choose no privacy rather than choosing incorrect compliance and risk getting shut down by the governments. And other problem is that all these privacy protocols are basically siloed. They're not connected, and they are completely disjoint. Whenever you want to move your assets from one privacy protocol into somewhere else where you want to use your assets, you have to step out like this naked guy running between two protocols. He was in the green one. He wanted something that is available only on the red one. So he had to completely undress before he can move to the next one and enjoy privacy again. So solution to the hard compliance problem, we at Mistcache, we're separating out the privacy layer, which breaks the behavioral linkability. And we use a separate compliance layer, which can be configured per jurisdiction, per use case, per protocol, however we need. And it's built for, we can build for interoperability from the beginning. So we can incorporate flexibility and interoperability into the core design and make sure that anonymity sets are shared, and you can move assets among the protocols without leaking any privacy. So now this guy can go to the red one without having to undress. So you can now accept funds on Ethereum and make and use those funds on an off-ramping service or any other service, let's say on Base, and you can do it without losing any privacy, and also you can do it in a single transaction. So we are building essentially Visa for on-chain privacy, and without privacy, crypto will become the most potent data mine for massive exploitation and manipulation. If you're interested, find me after the session for any technical discussion, or connect with me on Telegram or X. And here's our Telegram community group if you want to do some open source contributions, stuff like that. Oh, and also if you're participating in the hackathon and you want some real easy plug and play privacy, feel free to go to github.com/mistcache/SDK to have this plug and play financial privacy work for your project. Cool, I think finished on time. Oh, any questions? Yes, please go for it. I'm also an applied cryptographer, so if anybody has questions, go for it. Applied, not the, but go for it, yeah. Cool. My tips? I think there shouldn't, we should not need any tips. It should just work flawlessly, and the user experience should be as smooth as possible. Yeah. But today, sadly, the stuff that you would want to need to interact with the real world, with stable coins and stuff, you will have to sacrifice privacy. Yeah. But there are some tricks where you can use fresh addresses, and when you move the funds, you have to make sure that you don't move them directly with your old address, because that's just going to connect it with your previous one.
There's no way to break the chain because it's all linked together.
Yeah, but it's
you have cash, unless you move the cash at one stage,
mm-hmm.
right? Then you deposit to another wallet, a new wallet, right?
Yeah, but if you deposit, it's going to get linked. So you want to use something like Tornado Cash or something like Privacy Pools, which is pretty decent and also is sort of not actively compliance center, like anti, you know. Sweet. Good talk.
So that is the last talk for the Web3 track. The next segment is actually on Lightning Talks. We'll start at 4:40 according to the schedule. Right, so there's a 5-minute bio break.
Yes, hello.
Because it's a 5-minute talk, so we need to quickly get the speakers to line up. So after the first group, Mr. Dinan J, are you here? Okay, cool. Okay, and after that will be Mr. Lucia. Lucia?
No, but yes, 450. Someone else.
No, 455. 455. Yeah, okay.
55.
Oh, yeah, this is Singapore time, so it's 1 hour.
Yes, I didn't see. Yes, but yeah, because it's 55 now.
Yeah, according to the live website, it says 55, but it's okay. You can just be around.
For some reason,
I can just use someone else's website.
So welcome to the Fast and Furious Lightning Talk series. Right, so we have the first group.
Hello everyone. So we are from FOSSASIA, and we are all of us are from India. Yes. So myself, Arnav, Saksham, Vedansh, and Srivatsav. So Vedansh will begin on Scrum Helper.
Hi everyone, I'm Vedansh. I work on Scrum Helper at FOSSASIA. Scrum Helper is a small tool that helps open source contributors generate structured progress reports directly from their Git activity. In open source projects, activity is actually very visible. Contributors push commits, open pull requests, and discuss issues across many repositories. But when it's time to write a weekly update or a progress report, all of that work still has to be manually compiled. Scrum Helper tries to solve exactly this problem. Scrum Helper fetches commits, pull requests, issues, and reviews from GitHub or GitLab. It groups activity within a selected time range and automatically generates a structured report. Instead of writing updates manually from scratch, contributors only need to refine what's already generated. The goal is to keep reporting lightweight. It doesn't introduce a new project management workflow. It simply organizes work that already happened. Now, if you're interested, please go on GitHub and check out our extension. Thank you.
So hope you guys do use Scrum Helper. Okay, so I'm Arnav Angarkar. So I've been contributing to Event-A since a few months now. So I was really new to open source before I started contributing. So I'm in my second year in IIIT Dharwad, and I'm doing a computer science degree there with a minor in quantum computing. So the first time when I went to Event-A, like I had learned some Django and had made very small like blog projects and stuff. But when I thought that about open source, we as students use a lot of open source software since we like free stuff, right? So the first time I opened Event-A, so it was a huge code base, a complex architecture, dozens of issues. So I felt overwhelmed. What if I break something? Like what if something goes wrong, right? So then slowly I realized you have to start small, read small issues, try to see some UI issues, and fix tiny things one at a time. Then eventually I realized that the real challenge is not coding, right? Nowadays coding is not the real challenge. The real challenge is getting to know the workflow, the way things work, and how discussions happen, how to talk to and communicate with the maintainers and other contributors, right? So how PRs evolve. So the main thing is trying to get to ask the right questions to the right people, right? So you eventually explore different areas. Once you start contributing to small issues, you explore different areas, and yeah, you explore code, you explore testing, you explore documentation, and eventually you realize you are committing code to a real world platform which real people actually use. And the best part is learning from the maintainers and learning from the people reviewing your PRs, right? Meeting more contributors, right? So this is the featured speakers is something I have brought back into functionality in the dev system, dev.event-a. So the new event-a system, the featured speakers, this is one of the feature I integrated. One of my PR was this one, right? Then I also came up with one of my PRs was on the telemetry system to manage different deployments of event-a and different instances at different various places, right? So yeah, and you will get to a part where you are stuck, right? And you don't know, like you don't know what's going wrong, and it's such a huge code base, and obviously being new to all this and such a complex architecture, people will request changes and you don't know what's going on. So in this period, the seniors and the more senior members definitely help. So I would especially like to thank Mario, Hongfuk, Srivatsav, Saksham. He helped me a lot in the initial days, and Kwan. He is an excellent reviewer, and I learn a lot from his feedback. Yeah. So thank you all of you. And so open source is a place where, you know, a senior engineer as well as a newbie like me can you know, contribute to the same code and the same issue, and you are working together. So you don't see this type of architecture in the corporate systems, or even during when I learn at school. So there are different teams of different levels, but over here I directly contribute with senior members like Srivatsav and Kwan himself, right? So for someone new, my advice would be not to be intimidated, get started with small issues, and yeah, I guess that's it. So the fun fact, the first time I opened Event.a, it was such a big code base, I just closed it in 30 seconds. But eventually, I have contributed to more features. So yeah, getting started is the point. Yes, I would like to hand it over to Saksham now. Thank you.
Hello guys, I am Saksham. I am currently a last year student at IIT Madras, currently pursuing my majors in data science. So on the Event.a system, I was working on deploying a new version for schedule editor and the public schedule. So here are some of the features that I have implemented in the last few days. So there's like added supports for calendar exports. Older version management is now added to the platform, and we have added like start sessions functionality, where we introduced various filters, like there are tracks, rooms, recordings, and like translation related filters added. There's per day scrolling now implemented directly, which was not available earlier. We have also implemented density sliders for people who like to see a lot of content on a small screen. So there is search, print, and full screen related functionalities added. I have also added changes to the video platform as well. So it has been a very good journey so far. So here's Srivastav for more.
So hi everyone, I am Shivatsa Ashwin. So I've been working on the Event.a project for more than 2 years now. So one of the main areas of focus in Event.a was, so a brief history of Event.a is it was divided into 3 different components. One was the ticket generation component, where you manage the ticketing for all the events that you do. And one was the talk, where you manage the speakers, the sessions, and how they apply, and how other reviewers review the sessions. And the other component was the video component, where you can live stream your events, you can have chat rooms, and all of these things. But one of the main components that like event organizers look forward is to like have all of these together unified in one single place, so it will be easier for them to manage. So this year in GSOC, mainly one of my main goals of the project was unifying all of this. So this unification done on a very core level, in the very base model level. So compared to the previous implementation, where the talk component was using a separate event model, and the tickets tickets component was using a separate model, all of them has been cleared out, and now all of them are using the base core level models. So the system is completely in sync. And now for the attendees or the speakers, they just have to use one single sign-on, where they can manage their tickets, where they can manage their schedule, where they can review stuff if they have the reviewer access. Everything other completely can be done in one system. So we have also added a lot of customization options on how organizers want their events to be visible to the attendees, or how they publish it, and like we have updated start page where we can like feature particular events. We can see past events. So the overall flow from publishing to managing and like closing the event has been much improved with the latest changes. And one of the main new concepts in Event.a is the plugin ecosystem it has. So we have added a check-in system for Event.a, where all the tickets in the Event.a platform can be checked in, and the check-in system is built in such a way that if there are no people, we can run it in kiosk mode, where the printing can be automated, or if we have the enough staff for an event, we can still do manual check-ins, where if some people don't have their kiosk, we can just search and like fill in their names and like continue on with the check-in process. So the whole starting from ticketing to the check-in to attending the event and like managing the schedule, everything will be a seamless workflow. And coming back to the plugin system, Event.a supports a wide range of plugins. As part of the unification, all the component-specific plugins has been also unified to work on a common level architecture. So things such as exhibitors are now added to the event level rather than particular places where you just see and view exhibitors, but now exhibitors can actually be added. We can lay out a floor plan act where exhibitors should be, how they should, what access they get. So now we have more plugins. We have also provided a large scale of payment plugins. Event now even supports crypto payments. A very good plugin system has been also added to the ecosystem. So if you guys are interested in Google Summer of Code, are just interested in open source in general, you guys can check out Eventia. It is a very active project which has a lot of contributors opening issues and PRs every single day. So this is a good thing if you guys are interested and you want to contribute to it. So thank you. Hope you had a good session.
Well done, perfect timing. Thank you. So next we have the second speaker, Mr. Dinan.
Just before we start, can we clear maybe a slight path over here? Otherwise, there's quite a big of disruption when people come in. So maybe one path, a gap over here for people to walk through. Yeah. Here you go.
Okay. So I'm going to present a visual editor for headless CMS, and what I'm actually interested, it is on GitHub. It's not quite released yet. It's under active development, and I'm kind of interested in anyone who is perhaps interested in collaborating or has a use case or has ideas on where to take it. So if you're interested in that, come and see me afterwards. So CMS is maybe not everyone's cup of tea. But essentially, if you look at the space of where CMS is at the moment, everyone knows sort of WordPress, I guess. If CMS is all about getting editors being able to add content to websites, and then developers or integrators being able to create the theme and the look of the website and getting those two things to work together. And you have traditional CMS like WordPress and Drupal over here, which is both a big learning curve, and to get it to be visual, they have visual things and work, but it has a lot of integration issues. It says a lot about how your HTML should work. Then you've got things like site builders. You can have site builders in WordPress, but you can also have things like Wix and Squarespace. They give you pre-done themes. It's really nice to use, but you're kind of limited in the theme, like the look and feel of your website. It has to work the way they want it to work. And then you have headless CMS. Headless CMS is more development. It is like you're using front-end technologies like React and Vue and stuff. You have ultimate flexibility, but a lot of the time, the editing experience suffers a lot. You end up with a form on one side, and you know you can't sort of visually inline WYSIWYG edit as nearly as much. So I tried to solve that, and I tried to solve that in a way that it's still decoupled. It doesn't require any particular technology. You can do it in any front-end reactive framework. So for those not familiar with headless CMS, what you're talking about is you have a front-end which runs on one server, which uses a front-end JavaScript technology, and then you will talk REST API or GraphQL to some back-end system, and you have your rendering, you have your storage separated. It's not one big monolith together. So if we look at this example here, what's running here is Vue, and the editor is React. And if I click edit, it'll go into edit mode. And what you see on the side here is what you might see with a typical headless editor with the ability to change things here, have that change on this side, maybe with a live preview. But what you can do here instead is you can click on blocks, you can edit directly in here. Sorry, this is hard with one hand, but you can drag and drop blocks around, etc. All of that sort of stuff you can do, and the nice thing about that is that, so if we look at this one-page example here, right? Here's what you got to do to make that happen. So the first thing you do here is you're looking at the window name and you're saying, okay, am I in edit mode? If I'm in edit mode, what I'm going to do is I'm going to connect this small bridge here, which does a communication across the iframe. And we're also going to send a definition of the blocks. So this is a block-based editor. Each block has its own set of fields and so on. And then on edit change, we do the render. If not, we just call the API directly and do the render. So you're using the same render routine for either, regardless of whether you are in. So you're basically reusing the code, but what you're doing differently is that you add a few tags. So you add a block UID tag. Where's the block UID tag? So block UID, and that says, okay, this is the thing that's a block, and that allows the clicking and selecting and dragging and dropping. You can say block edit text, and that's going to do the sort of text editing. You can add block link, block image, and that will do inline uploading of images and so on. And that's all you need to do. And this is one page example. That'll work in Next.js, that'll work in Svelte, it will work in plain HTML, CSS. It's not requiring any base classes, any components that you have to install. It's not using a SDK per framework. It's just pure JavaScript. And that's it. Thank you. My name's Dylan J, and Predagov is the company. So if you want to talk to me, let me know.
Hello. Yep. All right. Thank you, everyone, for joining. My name is Lucia. I'm a technical program manager for the Council Democracy Foundation, and today I would like to talk to you a little bit about what we do. How does this? Yeah, so Council Democracy is a free open source platform for citizen participation, originally developed by the municipality of Madrid in 2015. Since 2019, it's being maintained by the Council Democracy Foundation, headquartered in the Netherlands. However, we are a fairly distributed team. Since then, it has been used by at least 350 governments, municipalities, organizations. I say at least 350 because due to the Affero license, we really don't know how many there are. Everyone is welcome to use, modify, and distribute their own version of Consul. But more often than not, we find out that there's a lot more cities using the platform than we even thought about. A couple of things that are not here. We won the United Nations Public Service Award in 2018. And we also promote neutrality, transparency, inclusion, and of course, free knowledge and open source software. Here you can take a look at what we already know. Now, I would very quickly like to point out to the fact that this region over here seems a little bit empty, yeah? Maybe we can change that. Yes, yeah. So, for the sake of time, I'm going to go really, really fast on this. These are our main features. If anyone wants to know more about this, we have a booth over there, and you are welcome to find out more. Well, looks like my abilities are not particularly good with this. Well, I guess you can at least take a look at this. I'm very sorry. There. So some of the challenges that we are facing at the moment. The number one is a no-brainer, the funding. People say, okay, you're a non-profit organization, free open source software. Where do you get the money from? And the no-brainer answer is, what money? Now, of course, most of you already know about this one. But the lesson learned from this is when resources are lacking, the community is our biggest strength. Now, contributions. Everyone would say, okay, if you give so much, then people are going to contribute back, right? Well, not really, not always. And surprisingly, one of the reasons is that people are sometimes scared of having their code rejected or even reviewed. And the second one is, regarding contributions, is, okay, sometimes we do get contributions, but they are from versions of Consul that have been customized so much that they're very difficult to actually get merged. Or sometimes people don't work on the UI tests, right? The workflow runs and then the UI tests are breaking. How do you tell someone that is giving this for free to fix the code? So the lessons learned from these contributions are contribute, but if possible, contribute early and consciously. The last one is not necessarily a lesson, but it's a very interesting one. Consul is built in Ruby on Rails. And it is getting surprisingly difficult to find any kind of Ruby dev, especially in the West. There is still a little bit of movement here in Asia, but this poses a lot of complexities when we actually try to get contributions. Now, that being said, there's a lot of other things outside of the Ruby stack that can be done. So please, if you would like to, get engaged. Now, the last lesson learned that is not pictured in here, I like to use the term input-output ratio, but what I actually mean there is size impact. So we have basically changed the lives of many, many people with a very, very small team. And this proves the power of free open source software. Thank you very much.
Yeah, okay. Hi everyone, I'm Le Yi, and today I'll be sharing about my project, Vibe Engineers. So a bit more about the team. We are a team of 2 platform engineers from CSIT, which is based in Singapore. So as part of our day job, we work a lot with open source products such as Keycloak, Postgres, Kubernetes, and many more. So in our spare time, we decided to experiment with our very own open source product. So before we dive in, I'm sure many of you are familiar with the term vibe coding. So you open a chatbot, throw in some prompts into the AI, and it just generates the code for you. And honestly, it's amazing. You can prototype something within minutes. But if you actually tried developing something that is slightly larger, you might notice a problem. So vibe coding produces a lot of code and products that look very interesting and fancy, but if you actually put them together, the logic underneath might be a little fragile. And that might be why vibe coding comes with a bit of negative connotation. But what if you can take the creativity of vibe coding and then add some engineering structure to it? So this brings about the terminology vibe engineer. So for vibe engineering, instead of fast and loose chat-first AI, it is something with a bit more design and structure to it. And then if we can apply this to code level, can we also apply this to runtime? So this is what sparked our idea for Vibe Engineer project. So Vibe Engineer is an open source toolkit for AI in the runtime. So we embrace a few key ideas. We want it to be playful, non-deterministic, adaptive, and boundary pushing. So introducing the Vibe toolkit. So this comprises of a few small Python libraries that help to structure AI behavior at runtime. So let's dive into the first one, Vibe checks. So in traditional programming, the control flow is built on top of very deterministic logic, such as if, else, loops, and etc. And this works great if the condition you want is very well defined. But what if you want something that is more semantically complex? So for example, in our code snippet over here, we want to check if something is a valid dog breed. So to do it, we will likely have to hard code a giant file, keep it updated, deal with the different spelling variations and aliases, etc. Or you can simply let LLM evaluate it. So vibe check allows you to express it in natural language. So when the LLM evaluates it, it will return a true or false, which you can then use it programmatically in your control flow. But can we do more than true and false? Can we generate output that is more dynamic? So this brings about our second library, VibeGen. So sometimes our challenge isn't just control flow, it is implementing something that is more semantically complex, or just very tedious for you to code manually. So for example, in this case, we want to a function called define antonym. So a more deterministic implementation would mean to maintain a large dictionary, deal with all the different language nuances, as well as edge cases, etc. So for VibeGen, you simply need to decorate your function, and it can then generate the output based on your function signature and context. But VibeGen is not just limited to language tasks. It can also be used to implement many well-understood logic, such as mathematical operations, or just common algorithms, without you having to explicitly implement them. So moving on to our next library. So many times when we are developing, we don't always get the output that we want. So the function can fail because of various reasons, such as network instability, or maybe the API just isn't there. So at times like this, you'll need to implement some sort of retry mechanism. So in this case, instead of having a very rigid retry logic, instead of implementing a rigid retry logic, we can now define policies in natural language. So for example, we just specify a retry decorator with a max retry of 3 times.
Yeah. Feel free to engage then after the session. Okay. Thanks. Okay, so our second last speaker is from Creative Thailand.
Hi. Okay. So my name is Tay. I'm a CEO of Creative Lab TS Group, and I am also an artist. So maybe I'm the only one here who can fixing printers or Wi-Fi, I don't know. But anyway, so why you guys are technologists, right? I'm an artist. So maybe while you guys are trying to decoding AI, I try to decode myself using AI. So the question I want to ask you is, what is the result of using AI to decode humans? That is kind of my work. You know, 2 years ago, when I was 16, when I was in high school, I created Creative Lab TS Group. We used to go to promote multidisciplinary fields in Thailand. You know, how to use AI to connect scientific and artistic. One of the first, actually the first project that I do at this startup is we're trying to decode past memories. The project is called Harmony of Mindscape. We're wondering around the question of how if music contains memories, how can technology capture it in tangible way? So the project allow users to listen to the music that they have memories or something that they're keen on or something, and record their brainwave data live, and then use AI to turn those data into 3D sculptures and 3D printed it. And then we co-working with an artist to exhibit it in the concept of time. And this project is, you know, the 3D printed are, you know, reflective of something, someone, or actually anything. And this project is inspired me to founded a lab in my lab called Cognitive Programming Interface among all the research clusters. The first project of cognitive programming interfaces is we're trying to decode future. The project is called Miss You a Mirror Dream. The project is we're trying to explore how quantum science can help us understand more of the correlation of 2 persons. You know, we let 2 persons share the same situation, sleep in the same room, and then record their brain data and use those factors that we collected from EEG machine to form a new quantum mechanics formula, and then trying to find the correlation, the Hamiltonian correlation of 2 persons. And another project is from futuristic culture interface. We're trying to use AI to create alternative situation of the characters in my, actually the legend story of my hometown. How about to decode the present? Because, you know, last project is kind of to decode past and the future, right? How about the present? So the project, this is called Speed of Vision Ganga. The project is to like explore if the AI mind is trained from a psychologist, but the avatar is something that people are into. Are people gonna, you know, be more into talking about themselves more? And actually is, you know, we use our Ganga spirit as the avatar. Another project is how can we archive the data of the, you know, political issues in terms of a dance performance between a protein structure 3D printed robotics and a traditional Thai dance called Khon. You know, it's really interesting project. What about to decode society? This project is how we can use AI to extend religious. We use AI to clone, how can we use knowledge from a deceased monk to create a new amulet and then co-working with a monk, a real monk, and make it work, something like that. And this project extend to another project that we use AI to learn what life really means in Buddhism and create a digital avatar or something like that. At the end, of all of the project, I think AI is not just a technology. It helps me reconcile, reflect, and even renew what does it mean to be human. So, in this time, I think AI is not just a technology, it's a tools that connecting us present society to the past and the future. And because, it's not the time that you have to choose to be in the past, to be in the future, to be with AI, to be a human, but to be is not, or not to be is, that is the question. That's why Shakespeare is speaking to us. Thank you.
We're going to have our last lightning talk speaker, probably the youngest. Yeah, in high school. Okay, cool.
Hello everyone, my name is Kannan. I'm a student and developer from Singapore. I'll be talking about how to use open source LLMs to make personalized education more accessible. So I want to take everyone in this room back to 1984. Back to 1984, when Benjamin Bloom had enough data to plot the performance of students taught individually and in a conventional method. Students were taught individually outperformed vastly the students who were taught in a conventional method, where there was one teacher for every 30 students. In simpler terms, an average student from the one-to-one tutoring was better than 98% of the students taught in the conventional tutoring. But which brings us to the question, is AI really effective in tutoring? Because we don't want our children and students learning from a source which cannot even teach. Turns out researchers from Harvard used a custom-built AI agent and in-class active learning and compared the two results of the student performance in test. Students who used AI to learn vastly outperformed students who learned in class, and also they took lesser time, on average 50 minutes to learn, whereas students who learned in class took 60 minutes to learn. Teachers reported a 40% reduction in the time they spend in planning the lessons and 40% increase in satisfaction rate after delivering their lessons. Now, why not close source AI? I would be skipping this because of time, but it's mainly because of privacy issues and cost dependency, because we don't know how much AI is going to cost beforehand due to dynamic pricing and tokens. Now, the common word among developers is that open source AI models are dumber. I cannot use the word dumber, but not reliable compared to closed source AI models like ChatGPT and Gemini. While I agree with that, the base models of open source AI are not reliable. But according to the paper LoRaWAN published, they took 10 different open source AI models, which included lower parameter models like Mistral 7 billion parameters, and fine-tuned it across 31 tasks. So they got 310 unique fine-tuned LLMs, and I put some data up there, but on average, the best open source fine-tuned AI model outperformed GPT-4 by on average 10 points. Now, enough with technical, but what is Socratic tutoring? Conventional tutoring focuses on the teacher standing in the podium and lecturing the students, but Socratic AI tutoring does not tell students what to think, but how to think. And this is an example of Socratic tutoring. Here is a direct instruction tutoring, which would be the conventional tutoring when I ask an algebraic question, and the teacher just says, divide both the side by this number, add this number to both the side, and you'll find the value of x. But Socratic tutoring, on the other hand, would not give the direct answer, but would teach me through questions such that I don't only answer that question, but also learn to answer such type and even in some cases advanced questions. Now here in FOSSASIA, I would like to introduce a new architecture called glass box learning architecture in contrast to the black box LLM. So what happens when the student asks a question is that using retrieval augmented generation, it goes to VectorDB, where all the learning sources of all the students, for example, textbook, videos, and lectures would be vectorized and stored, and then there will be retrieval from that database, which goes to a fine-tuned Socratic tutor LLM, whose response would not be a direct answer to the student's query, but would be a question, like we saw in the previous example. Then there will be a guardrail check which is initiated, which would check that the response given by the tutor LLM is not a direct answer, but in fact a question. If it's a direct answer, it would go again to the Socratic tutor LLM, and this process would continue until a Socratic response is given. And then the main reason for calling this the glassbox architecture is that this entire process would be logged and stored so that the teachers and the parents could see what the students and children are asking AI. And this is actually inspired from the Khanmigo app released by the Khan Academy, which is also an AI tutor. So thank you, everyone. If anyone would like to contact or connect with me, here are my socials. Thank you.
Thank you. Perfect timing. So that ends our lightning talk series. Our last session in this room is about the Tor project. Mr. Roger. Okay, cool. Yeah, here.
Do I have a session chair, or am I just me?
Sorry?
Do I have a? Is there a version of you for me, or do I just begin?
Yeah, you can just take over. No worries. You'll be using your own
grab a
laptop,
mic.
or
I'm just talking.
Okay,
I'm just
sure.
talking.
Sure. So yeah, please feel free.
Beautiful. Okay, and I noticed that they changed. Originally, I had 20 minutes or something, but they just turned me into a panel by myself of 45 minutes. So you're welcome to stay as long as you like, and we can talk about whatever you want to talk about. So hi, I'm Roger. How many people here saw my Tor University relay campaign discussion this morning? How many people here saw my Snowflake discussion yesterday? Fewer, but still a few. Okay, great. So, hi, I'm Roger. We can talk about whatever you want to talk about. We could talk about censorship. We could talk about the importance of distributed trust. We could talk about surveillance capitalism and why large corporations are hurting the world. We could talk about local politics, or the disaster that is my country, the US, and what we're doing. There are a lot of options here. I have a microphone, and maybe we have a second microphone that we can give to people. Does one of these work as a microphone? So. You are, in fact, oh, hello. Yep. Beautiful. Thank you for being my session chair. That's okay, yeah.
This is, in effect, the tail end of the security and privacy track, which was over in Hall 3, except that we had to give it up for the social event. They're currently moving all the furniture.
That makes sense.
And so
yes.
It's not without reason that I assist. Questions?
I want to know your opinion about the recent age verification methods that are coming that looks to be more spying wrapped into a more sellable concern for the population.
Yes, it's a great question, and it doesn't look good. There's a repeating pattern where people try to control the population. And whether it's we have to censor the internet so you can't get to these websites, or we have to make sure that there's a driver's license for the internet. I don't know if you remember that phrase from 10 or 15 years ago, but it's the same thing. They keep saying, how about we constrain people and watch them and make sure they can't do things on the internet? So this one is particularly pervasive, is a problem, because they're going to the big companies and saying, you need to stop people from reading your websites. And 15 years ago, the web was much more distributed. Everybody had their own web server, and you'd have to go to each of them one at a time and say, you have to censor people. But now the web is run by Cloudflare and Akamai, so you just go to them and they choose whether the web gets censored. So in theory, there are worse ways of doing it and better ways of doing it. Like the bad ways are upload a copy of your passport in order to, or turn on your webcam and we'll use AI to decide if your face looks old enough, or like there are some garbage ideas that they're proposing. In theory, you could do some sort of zero knowledge proof of being over this age, but that still requires a global public key infrastructure where everybody's been given these certificates, and the workaround is that you're going to use your parents' certificate. So what are they actually doing? Is it going to accomplish the goal? No. Is it going to have a lot of bad privacy side effects? Yes. So it's another terrible move by politicians who don't understand math. And yeah, so there's more rant to happen there, but there are many of you, so I don't want to allow
shocking
this to
revelation.
Yes.
Others?
But I guess the final answer is that's a great example of oppression by Western governments. Here we are, maybe we could talk about the Vietnamese government or the Chinese government. We don't have to. We can talk about the French government, the Australian government, the British government. Yes?
Hi, maybe somewhat related to this and about like centralization of critical infrastructure in like a few corporations. Do you see any potential in like blockchain, Web3 stuff to help fight this trend, or is it hopeless?
That's a fun topic. I've spent, over the past couple of years, I've gone to a bunch of Web3 conferences to talk to those folks, and a lot of them have overlapping values with cypherpunks and privacy-oriented people. The strange thing about the Web3 cryptocurrency world, they're really into distributed trust and decentralization, but one of the unshakable assumptions is that capitalism is a necessary step to whatever you're going to build. And I come from like the Debian free software world where community is a necessary step. But once you start adding money into things, you're probably going to screw it up. So I had a lot of debates with them. Like every time I talk to a Web3 person about Tor, they're like, Tor is great, but you know you're missing something. You need a token. If you just had a token, incentives would be solved. Like everybody would want to run relays. You'd have a lot more relays. Everybody would try to, they'd speculate on your tokens so you could make money and you wouldn't have to do fundraising for your nonprofit anymore. And the problem with that is that tokens produce victims. Most of the people interacting with the tokens are victims. So I've been trying to argue with them about why capitalism isn't actually going to solve these things. So assuming that you need to have the whole incentive structure that people trying to make money, assuming you need that in order to accomplish your goal is really worrisome to me. So I'll give you some examples on the Tor side. Imagine a world where you run relays in the Tor network in order to make money. So the first step is you say, oh, that's great. There will be more relays, right? More people want to make money, so they'll run more. But they're all going to go to the same place in Germany, which is cheapest, because their goal is to make money, so they will lose as little money as they can in order to maximize their payout. And so then your response is, okay, great, but your utility function should have something to do with geographic diversity. And that way, if they're running in a place that doesn't have very many relays, then they get paid more, and that way you're incentivizing the right thing. And that's cool, but I was talking to a relay operator recently in Sweden who had hacked the GeoIP databases to list his relays as being in Antarctica. And he did it because it was funny, not because he was going to make 10x the payout. So every time you're thinking through, so in economics the phrase is mechanism design. Every time you're thinking through how to incentivize what you want, you have to think through how robust your ground truth is. And the GeoIP databases are garbage, so you can't actually incentivize geographic diversity because nobody knows where IP addresses actually are. So I don't know how to build a system like that. And the Web3 people that I've talked to are very excited about vision and don't care about details like facts. So those are some thoughts on the Web3 communities. I'm glad they exist. They seem very excited. We in the world need more enthusiastic people.
factual tedium. Dear, dear.
So it's the first time I heard about this university campaign. I think it's very attractive. I can see because universities, they have a lot of bandwidth, and usually they have spare bandwidth, like they have big...
Some of them do, some of them don't. South Africa will disagree with you.
Okay, but
yeah.
usually like those university networks where you have an ISP for the whole country that serves the whole, connects all universities. What I'm concerned about, but maybe it is not a concern, and you will for sure be able to answer that, is that those relays will be under control of more or less the government. And isn't there a risk that if too many of those relays are run by universities that are run by maybe a government that is not to be trusted, and as we know, in recent times, a lot of governments are turning into the direction that they no longer can be trusted. So in terms of timing analysis, I know there has been a case in Germany where someone has been exposed by connecting to controlled relay nodes. So can you answer how realistic that is?
Yeah, so it's not obvious to me that university professors are controlled by governments. In fact, I might think of them as more independent than the average corporate internet user. So it depends what country you're talking about, but a lot of places professors have their own academic freedom and their own research projects, and they decide what to do. Mm-hmm. So that's the good news. The bad news is it's the same internet that everybody's using. And the internet is not, like I used to make gestures like bouncing around the internet. But actually, if you're going back and forth over the same fiber through the same ocean, then you're not bouncing all around, you're constrained because there aren't that many fibers between oceans. There aren't that many companies that run web servers. There aren't that many app stores. There's a trend toward centralization in all ways lately. And so the bad news is you shouldn't worry so much that a professor is running a relay and what if the government has access to that. You should instead worry that the professor sets up a relay on a piece of the internet that the intelligence agencies are already invested in watching. Like they had other reasons to spy on that cable, and now there's Tor traffic, so they just get it for free because they're already surveilling the internet. And as the internet centralizes more and more, it becomes more attractive to be surveilling that. So I think we, Tor, have a fundamental problem as the internet centralizes, and our model is distributed trust, is decentralized. The internet itself is constraining how safe the Tor network can be. And that trend seems like it's getting worse, not better. So I think having a diversity of relay operators is really important. And I think universities can represent a new angle of diversity that we don't have enough of right now. But I'm especially worried that the internet itself is easy to surveil. So you asked in particular about the German situation where it seems that maybe they did some sort of traffic analysis thing. I've never gotten any actual facts out of that. I talked to a CCC guy who said that he read the report and he thought certain things, but I don't know that he understood everything. So I'm treating this as another FUD, fear, uncertainty, and doubt. And until we actually have details, so I'll give you another example on the extreme end. There's this Europol guy who keeps doing press releases saying, Tor is totally broken, can you all switch to VPNs? And every time I do a talk like this, there's somebody who's like, I heard Tor is broken, I heard you shouldn't use Tor anymore. Think through that guy's incentive. That it's pretty clear that guy's trying to bust somebody who's using Tor, he can't, and he wishes we would all stop so that he could go to the VPN and find his person. So why does he keep on saying that he's got his own goals? So is there some German government group who's like, oh yeah, Tor is totally unsafe, traffic analysis, wave hands here? Maybe. I don't want to say that Tor is perfect, but I never learned enough details about that case to have any confidence that it ever happened.
That's a very good statement.
Mm-hmm.
Thank you for answering the second question that was not really
it seems like there's a trend on kind of like all the topics that we have touched, and it all comes down to centralization of infrastructure. Not all, but it's a big part of it. What do you think about mesh networks then? How about we decentralize the infrastructure itself? And is Tor, or what are your thoughts maybe from Tor or personal about using mesh networks? I mean, of course, if you're using decentralized infrastructure, you also worry about the protection of the data that you're relaying through who the hell knows which infrastructure it goes. So Tor seems like a fairly obvious layer on top of this infrastructure. What are your thoughts on that?
Yeah, so I think mesh networking, Meshtastic, and so on are awesome, and I think it's great that people are exploring these things. It's not obvious to me that we can replace Tor with something mesh networky, and the reason for that is scaling geographically. So the reason why Tor is safe is we have so many relays in so many places around the world that not very many adversaries have enough of view of the internet to be able to see the traffic flows in enough places. So internet shutdowns are getting worse, and we need stuff like Meshtastic. But years ago, one of the State Department internet freedom funding people was like, what we need is a Tor network that we can deploy in Cairo, and when Egypt turns off the internet, we just raise the Tor antenna, and then everybody has Tor, and they're all like, they've got their privacy, and it doesn't matter that the internet's off. The problem is the Tor threat model. If you're an adversary who can see all the flows at every point, and you're good enough at math, then you can match up this timing and volume matches with that timing and volume. And even if you're hopping through 3 relays, if there's somebody watching the whole thing because it's just in one city, it's not going to work. So a mesh network that is local relative to somebody with a really big antenna that gets to watch everything, you can't use the Tor design to keep people safe in that situation. There are other cool anonymity designs that don't scale as well, like imagine you have 40 journalists and they all want to publish stuff and nobody knows which journalist it was. It's a cool research design. In practice, if you line up 40 Iranian journalists and you say, ha ha ha, you can't tell which of us published that, that's bad news for all 40 of them. So we in the Tor world want something that scales enough and has enough ordinary users that being a user isn't itself suspicious. So those are some thoughts. I think that the Meshtastic stuff is awesome, but I don't see it replacing the privacy properties of something like Tor that needs a global network to provide its privacy. Did that answer that? Okay. Maybe there's a Freifunk person here who has opinions.
Like I was going to mention Freifunk, which you then have like a dedicated fiber uplink to certain stations, but in itself it is a mesh Wi-Fi network. So you can have radio links, which in some cases maybe would that be able to enable this diversity?
But we're talking kilometers or 10 kilometers, right? We're not talking 1,000 kilometers.
No. I don't expect the Wi-Fi link to work that long.
Yeah.
And you need that diversity. So as long as you can control the people there, it is quite clear because you have the local thing with the...
There were some fascinating projects in Iran over the past months where people, like one person has a satellite connection through whatever Elon Musk's thing is called, and other people have a mesh network, and you can browse the web through that person's satellite network even though you're not really nearby. That sounds like a pretty cool project. Though I was also talking to people yesterday about how they collected a list of everybody with satellite connections and have been arresting each of them. So again, it comes down to the threat model. But having technology that can do that for situations where it makes sense would be great.
I'd only comment that for amateur radio operators in Georgia, I think it's now exactly the same problem.
Say this again?
There's a bunch of radio hams.
Right, a bunch of radio hams in the country of Georgia.
Georgia, I think, who are being basically rounded up.
Yeah, and don't just think about privacy against your government. Also think about having communication security while you're dealing with natural disasters or whatever the use case of Meshtastic is, why shouldn't we have communications metadata protection by default when we're doing ordinary activities that we do as people? Did you?
So can I go back to your? Yeah, can I go back to your question about verifying age, right?
Yes, the age verification thing.
Yes, correct.
Yep.
So what is your stance on it? Is that shouldn't do it at all, and if you should do it, what's a better way of doing it?
We need to think through, so it's not a technical problem, it's a social problem. What do we as a society want for ourselves? And looking at it as a technical problem of how do I stop you from having your traffic get there unless you can upload a something or other, it's at the wrong layer, because everybody's always, like, kids are great at working around these things. And they're going to keep being great no matter what your technical solution is. So you can't solve the fact that you don't want your kid doing that by blocking them. It's not going to work. So instead we need to think through, like, have the parents talk to the children and make decisions together, or something that is, it's not a power imbalance, but it's like and social fixes like that are hard. I get it. They don't work either, but you can't fix it by oppressing your children. It's not gonna do what you want, and it's not the way that society should be built. So I was arguing with somebody about the Australian age verification stuff and the Australia social media. You can't connect to Facebook in Australia unless you prove that you're a certain age. And one of the side effects that they were arguing that I hadn't thought about was it's no longer possible for the Australian schools to say, go learn about this, go to Facebook and learn about this, because they're not supposed to admit anymore that their students can reach Facebook. So they're no longer allowed to integrate required use of surveillance capitalism companies with their education model. So that's a pretty cool side effect, but then the person followed up with the great point of, if you wanted to ban using Facebook in school, then ban using Facebook in education. Don't try to add some age verification like workaround thing. Just tell the educators they're not allowed to require their students to log into Facebook.
Thank you. So, hope no one has asked you. But, so, I'm sure you know ECH, and ECH has been promoted heavily by the, let's say, the American big tech CDN community as a way to promote, basically, to give privacy to people that need to connect to a website without being discovered, outside of Tor, of course. So, and they claim we will have to implement ECH very quickly because this is necessary to save the lives of Iranian and Russian dissidents. So I wanted to know if you would agree with this claim or think it's maybe it's not completely true. And the other thing I want to know is that, I mean, as a response, let's say, from the ISP community, now there's at least a big ISP in Europe that is researching the possibility of rotating the source IP of the user, so that when you connect to their network, you will have a certain IP address for like 10 minutes, and then maybe you'll get another one, and I don't know if this would also, in your view, be a useful measure to make it harder to intercept you, or would also help Tor.
Yeah, so let me explain your question to everybody else here. When you're in the old days, you use HTTP to go to websites, and everybody gets to see not only which website you're asking for, but also there's no encryption, so they get to see what you're requesting, what you're doing, what page you're fetching, and so on. So then you switch to HTTPS, and there's a little lock in your browser. It's great, but the way that handshake works, outside the encryption, you specify what's called the server name indicator, the SNI, and you say the domain that you're going to go to in plain text, unencrypted. And you might say, well, wait a minute, why would you not encrypt that? And the answer is that the web server is serving SSL for many different websites, and it needs to know which certificate to give you. So that happens outside the encryption so that it can let you handshake with the right site. And the outcome of that is, if you're connecting to Cloudflare, Cloudflare hosts 1 billion websites, but you tell your sensor, your surveiller, which of those billion websites you're asking for, and that allows China to filter by SNI. They say, when you're going to Cloudflare, here's a list of domains that are acceptable, and here's a list that are not acceptable. And you'd think that having encryption would prevent them from knowing which website you go to, but it doesn't. So there have been some cool protocol proposals for encrypting which domain you're going to, while also letting the web server know which one it is, so everything works because of math. And then I think China blocked the use of these protocols. They're like, well, if you're gonna, there's this new protocol that won't let us filter, fuck that, we're gonna filter the whole protocol. And that was the end of that. I think Cloudflare added support for it, but if it's not working in China and Russia's gonna block it next, then it's gonna die. So this is, again, this goes back to the technical versus policy thing, where we, the engineers, can come up with better math, but you need to get it pervasive, or it's going to get killed by the authoritarian regimes that don't want that to be how the internet works. There's another one after ECH that's got some other name, and it's going to suffer the same fate. So maybe we just need to push it through anyway, but it comes down to a power thing. Does Google actually have, I mean, Google has a lot of users in the US, but I bet there's a browser in this continent that is a lot more popular than Chrome, and that's where those users are going to do. So I don't think Google's big enough to be able to push it through. I don't think Cloudflare is big enough to push it through. So it's not going to work, but not for technical issues. And then your second question was, what about cool other anonymity designs where you where your NAT rotates what your source IP address is very often, so that it's harder to track and trace you on websites. I've been talking to a Princeton professor about a design like that, combined with IPv6, combined with QUIC. And there are some cool ideas there. I think combining that with Tor would be even better. So at that point, you get the long-range privacy properties from using something like Tor, but even if they manage to break it, even if the people in Germany turn out to be right, then all they do is track back to he was a Deutsche Telekom user, and I don't know which one. So it'd be a cool security feature, but then it brings in the whole data retention question, where nations are going to their ISPs like Deutsche Telekom and saying, you have to, if they did this like IP cycling thing, they would follow it with a law saying, and you have to write down who had which IP address during which minute. Otherwise, how could we enforce the laws? So.
Like, by the way, that's already possible in Germany to do that.
To do the data retention stuff.
It's most providers do it every day. You get a new IP.
Yep. Yep.
Both IPv6 and IPv4. And I think there's always discussions about how long this data is to be retained.
But one of the cool things about QUIC is that you can move from one IP address to the other without noticing that you did. So we could imagine rotating IP addresses every 10 seconds. And then you just keep switching. And now it's totally unclear who had which IP address at what time. And you don't have to do it at the ISP layer. You can do it in the middle as the NAT. So the network itself, it's a network address translation. It just NATs you. At each hop, it could re-NAT you and change what you are every 10 seconds. Like, maybe that's how the internet should have been built, but it isn't yet. Maybe somebody here should build it that way.
That's a pretty cool idea.
Yeah.
Like someone in this room should start coding.
Yep. And if you use IPv6, you've got an infinite number of addresses to route through, and if you use QUIC, you'll never notice that you had to change.
Yeah. So you just mentioned that like a government might pass a law that you have, like ISP have to write down which IP belongs to which customer. I have a bad news for you. Such a law exists in Thailand, which is that although a little bit of grace is that they do rotate your IP every 24 hours for technical reason, but still that means nothing. And also ISP has to write down which IP belongs to which user anyway. They have loss retention of 90 days or something.
So do they only write down your name and the IP address you had and the time interval? Because I could also imagine them writing down every website you go to, and how long and how many bytes. These are how net flows work, and a lot of backbone ISPs log that also in the US, in the West, in Europe, and probably here in
I
Thailand.
do not remember what the law says.
Yeah, so I'm not too worried about the one that says you have to know which IP address you gave your person, because then tools like Tor let you protect yourself against that. Whereas I worry a lot more about backbone internet providers like Thailand Telecom or whatever it's called, keeping track of...
It's Nation Telecom. It's National Telecom.
Yes,
NT.
I worry about the National Telecom keeping flow records of this source IP address, that destination, this start time, that end time, this number of bytes. That's actually become quite common for... This comes back to the centralization of the internet issue, where as more and more parts of the internet keep flow records, and it started off as like an engineer security thing, but now they sell them. Now there's a business model, and now the CIA and the NSA go to Germany and buy their NetFlow logs. And at that point, they don't even have to, break in and spy on stuff. They just buy the traffic and do the math on it. So again, it's the centralization and the integrating of all of this stuff that makes me worried. So you've all seen your James Bond movies where they say need to know. After September 11, the US changed the phrase to need to share. And nobody made any James Bond movies about that, so it's not as cool a phrase. But it's moved from silo things to make sure everybody has everything. And that's really scary for privacy, but I understand why they took that approach.
You mentioned that the centralization of services is a problem that would reduce the possibility of the Tor network to provide the privacy that it provides. So my question is, as a provider, imagine I have my online to my e-commerce or something, and from a business model, I still need to deploy in AWS or Cloudflare or something, but is there anything I can do in my deployment so that is still not contributing to this centralization problem?
Yeah, that's a great question. One thing that each individual web server, website has been slowly, incrementally doing that can help you one at a time is set up an onion address version of your website. So I'll give you Facebook as an example. Years ago, they did a study of how people are connecting into Facebook.com. And they saw in, I think it was April 2016, they saw 1 million Facebook users logging in over Tor. And you might first be like, well, Facebook's business model is to spy on users. Why are they allowing Tor users? And the answer is Iran blocked Facebook a little bit earlier. So a bunch of users switched to using Tor in order to get to their social media. And that meant that the Facebook people, the engineers originally are like, I hate Tor. It makes it hard for me to do my job. And then they switched to, I love Tor. It helps the users reach my website. So it's a question of which security property, which reachability property you care about. But I mention it because Facebook used that study to decide to set up an onion address. So users clearly wanted their privacy, and Facebook decided we should give them the choices. We should set up the infrastructure so they can decide, do they go to Facebook over HTTPS? And maybe they're in Turkey, and maybe Turkish Telecom, man in the middle is the connection and gives them a fake cert, and it's not really Facebook. Or are they going to go to the onion address version, and because of the way the cryptography works, their Tor client can really verify that it really is Facebook that they're talking to. So it doesn't completely solve the centralization problem because you still put your onion service somewhere, and maybe you put it right next to your web server. But a growing number of like media organizations like BBC and Guardian and so on are running onion services to help their users have confidence that they're really getting to the right website despite interference that might happen between where the user is and where the website is. So it's not It's a complicated question, and it's not an easy answer, but that's something that a growing number of groups are doing. And part of the reason why I think of that and why I've been encouraging that pattern is because a lot of people hear onion services and they think the dark web, oh my God, I'm not going to do that. But actually, Facebook is on the dark web. And actually, Cloudflare runs a bunch of onion services. And whenever you go to a Cloudflare website over Tor browser, it, behind the scenes, redirects your traffic to go to one of its onion services. And this means you get better authentication, you get better encryption, you don't have to load down the exit relays because you're using a non-exit relay to reach the onion address. And that means that FBI.gov is on Cloudflare, so FBI.gov is in the dark web. What even is the dark web at this point? It's just another layer of encryption. So having more and more ordinary websites say, and of course I have an onion version if you want to use that, makes it normal. It goes back to the same argument as the EFF University campaign to normalize things, to make it, we've got 50 universities who are doing it, we've got 400 websites who are doing it. Of course everybody does it, it's not weird. There's a, thank you for being my, my session shepherd.
Hi, just to share, I'm BJ from the Philippines and I run a Python users group in our city. Recently, the Philippines actually is trying to pass a social media identification law, same as Australia, but instead of just for kids, for everyone. This is to quote unquote prevent the troll.
So this is like the Korea one where you have to show your identity before they'll let you post or log in or something?
Yes,
okay.
yes. They've already succeeded on the SIM Registration Act, which held on for a bit.
Yeah.
Okay. So going back, and we're some of our groups are actually trying to like campaign against it, but personally, I'm having a hard time trying to convince, well, even myself, but lay people who are not into privacy in the first place, or people that are more concerned of putting food on the table instead of like, I'm using Facebook for free, okay, they get my data, so what? So that kind of thing. How do you how do you talk to people or convince people to be concerned about their privacy and to combat these kinds of bills?
So are they requiring your identity and recording it next to each post? So if they get angry at you later, then they can figure out who wrote?
More of like when you register on a Facebook account, you have to connect it to a national ID.
And then they record that forever. And if they get angry at you later, they know who to blame.
Yes, of course. And we do have a Data Privacy Act of 2012, but it's more of a, it's implemented in terms of like if someone reports it.
Yeah, and Facebook probably doesn't care about your nation's
Or, yeah, nobody
Privacy
also
Act.
would dare to report it or something, or they'll have lawyers to
So the
handle
South
that.
Korea example I find really fascinating here. Years ago, they said, but there are trolls, and we need to make sure we know which citizen wrote something on social media, otherwise chaos. And they had such an explosion of identity theft because everybody was reusing their credentials to log into social media stuff, not just to show that you need a passport or pay your taxes or whatever. So reusing stuff that was intended to be kept secure in one context, in this new context, turned out to be a really bad idea. And they eventually rolled back their requirement because it was harming their society. So look into the details of that. But again, it's not a very satisfactory answer because that only matters if it happened to you. And everybody is going to say, well, I'm glad my identity didn't get stolen. And the problem is that the architecture of the system encourages more and more damage. But that's hard to argue with people who haven't themselves been hurt. So it's part of the broader question of how do we convince people that Tor matters? How do we convince people about privacy? And originally I was like, how do I can talk through like hypotheticals or whatever, but it turns out that the way that works best for convincing people about Tor is for them to experience privacy problems themselves, and then they decide they need it. But of course, they've already suffered whatever the problem is by then. So I don't I'll give you a fun example from the US side. One of my side hobbies is inviting myself to law enforcement conferences to argue with the FBI about how the internet works. And one of the arguments that you'd think would work really well, like, okay, so you're in the US, you've got some laws or whatever, you've got some judicial process, but what happens if you get a new president who doesn't follow the laws? and I tried, yeah, I know it's hard to believe, but what if? And I was trying that argument on the FBI people, and they were not impressed. So, but that should be one of the good arguments. Like, even if you do believe that your government is going to keep you safe in the current situation, what you're doing is building another database that later somebody's going to misuse. Later it's going to, like the new government isn't going to follow the same policies as the old one. So even if you're right and everything's fine now, which isn't true, but even if, then things are going to change later and you're not going to be in control of your data anymore. It's going to already be in some other corporation's database. And in your case, it's not even a Philippine company's database. It's some American company that doesn't care about any of you. So some of those arguments ought to work.
I've got at least 2 more questions asked, but I have a sort of side question. When did you last offer this totally hypothetical and completely absurd question to US law enforcement?
It was in,
if you'd care to answer.
it was like 7 or 8 years ago. It was in the...
Too soon.
Yeah, too soon. It was in the first Trump turn. It wasn't even in the second one. There are no law enforcement people who understand the internet and are willing to talk to me in the second term anymore.
I think it would be good to connect, it's more a question, do you have such a list, to connect examples in history where this has happened?
Yeah. So
and they exist. Like I myself, I come from Germany.
Yep.
Germans are very skeptical about privacy because in the last 100 years, 2 times we had a government that was maybe not as nice as the previous one.
And don't forget what the Germans did in the Netherlands. So the Netherlands did their census about like what religion people are, and then Germany showed up and said, hey, give me your census. And they built it under certain judicial assumptions, and then it got used under different circumstances.
Yeah. Or the Germans went to France, and there were lists of all Jews.
Yeah.
And there were people in France who were happy to provide that list of all Jewish people. And it was way easier for the Germans to did their horrible things in France because the list existed in the first place.
But even
nowadays, you don't need that list. If you want to go after Muslims, look after their customer card of the supermarket during Ramadan. What did they buy? And you will know.
Yep. And even like the more modern example isn't about governments doing that. It's about large corporations having their own data sets and having that be normal. Speaking of the supermarket side, in the US, we get quite a bit of discount if we use the supermarket card. In Europe, you get a lot less. And that's because of the privacy tracking, how much tracking can happen in each country, or rather how profitable the tracking is in each country. Other questions?
In the category of things I don't understand, I lived in Germany in around 2001, and one of the first things you have to do is register your address. And one of the second question, what is your religion?
Yeah. Well, they need to know for the taxes.
Yeah, I know why.
Yeah.
I later learned why. I was like, if there was one place on the entire planet where I would have thought the population insisted that the government was not allowed to have a list of Jews, I'm not a Jewish person, but if you're Jewish, you must write Jewish, I would have thought Germany would be the place. And it's not. It's very strange.
Yep. We have plenty of modern day examples as well. We don't have to go back 60 years.
Well, yeah, but it's a particularly acute example.
So we have a couple of minutes left, and I'll also be standing around afterwards, so easy to find. But but people who haven't.
Face.
Test. So I earlier asked you like what the impact of large language models might be on being able to track users, and I just thought like profiling someone on the non-Tor internet, non-Onion web, and profiling someone on the Onion web, assuming you can somehow correlate the sessions or match the sessions together. I think it was pretty difficult to profile people on a large scale, and that's now becoming cheaper. Do we already see signs that law enforcement or governments are trying to correlate public profiles to Tor profiles, and that way trying to match identities?
Yeah, that's a great question. I haven't seen any cases like that, and I would wonder, so usually technology goes faster than law, so I would wonder if they could use that sort of thing as evidence or just as tips. But you're absolutely right. So one of the ways that people try to track other people is you look at the broad set of activities they've done, and you hope that one of them identifies them in some way. So let's say you use Tor successfully many times in a row, and then one day you forget to use Tor. And then one day you put your phone number into something. And it's not a big deal because surely nothing's looking. But if you then, if the machine learning gets good enough to start just pulling it all together and comparing, then yeah, I mean, is the future of policing, they just ask the LLM and it knows even before you did the thing that you're likely to do the thing?
Yeah, or for example, journalists that are not that tech savvy, they use Tor for the parts they cannot have public, and they don't use Tor for the parts that are okay to do.
Yep, but they still write the same way and they still have the same sleep schedule. Yep. Yeah, I haven't seen it from the LLM side, but we have seen that story over and over in the past. I'll give you, so we're at time, so I'll give you one last story. I was talking to Nadia from Pussy Riot, who was a part of a Russian band that made Putin angry. And she was telling the story of hiding from Putin's thugs in Moscow for 3 weeks by moving around from place to place. They all used Tor. They resisted the Russian Secret Service because they couldn't break Tor and nobody knew where they were. And then one of them didn't use Tor that once, and then they got arrested. So OPSEC is a big deal in how to be safe on the internet. Tor is one piece of many different things that you need to do right. And part of the challenge there is if you're a military group, you've probably got training and resources and time to think it through and so on. And if you're a Myanmar blogger, there are a lot of things you have to get right. And it's hard to get all of them right. And I just saw the please end sign, so thank you very much for attending my AMA. And if there's an Ask Me Anything that you wanted to ask me not over a microphone with a video, I'll be around.
Thank you, Roger. This ends the relocated tale of the cybersecurity track for today. Those who have tickets for the social event tonight, we're on in about half an hour. For everybody else, hope we see you tomorrow. Good night.